It's your favorite NPC, and today I teach you everything you need to know about JavaScript. We go through variables, data types, functions, loops, if statements, arithmetic operators, and a lot more. Most courses don't really show how to use JavaScript for the web, but that's exactly what it is made for. So later in this course, I'll also show you how to use JavaScript to select, add, update, delete, and manipulate HTML elements directly on a website. So let's go. What is JavaScript and why should you care? JavaScript is the language that makes the web come alive. Buttons that react to user interactions, animations, dynamic user interfaces, all of that is JavaScript. And it doesn't stop there. The same language runs on servers, powers mobile apps, and can even be used for games. So should you learn it? In my opinion, definitely yes. JavaScript is one of the most widely used languages worldwide. It has a massive community, is essential for building websites, and opens doors to many other areas. So what does it do? It's essential if you plan to build interactive websites, APIs, games, chatbots, and more. In addition to that, the most important web frameworks like React are built on top of JavaScript. Learning JavaScript is one of the most important steps for any developer, and it's quick to get started. To get started using JavaScript, we will need a code editor, and you can use pretty much anything you like, and I recommend you to use Visual Studio Code. So you can, for example, go to Google, type in Visual Studio Code, go to the first link right here, click on the link. Once the page is loaded, you can press this download for Windows button, for example. Once it is downloaded, you can press on this file right here. Now we have to accept the agreement, press next, next, install. Now we're waiting for the installation to finish. And now we can just press finish right here. Your Visual Studio Code should look pretty similar to mine right here. Now we can install a couple of extensions that I recommend you. The first one is going to be the live server. So you type live server in here. Now let's select the first icon right here. And right here, you should have an install button. So just press this install button. The live server helps us to open an HTML file and get live updates for our website. So let me show you. We can create a project, for example, by saying that we want to open a folder. So we can go to the desktop, for example. Let's create a new folder. So we can, for example, say new folder, JS course. Let's create that folder. We're going to select this folder. And now we created our project right here. And every file we will create right now will be created within this folder. So we can, for example, create an index.html file. Let's create a basic template by using the exclamation mark. And now the power of the live server is that we can use open with live server right here. This will open this inside of a live server. And every time we have changes inside of our document, we just have to save and the live server will automatically update our website. So this is the power of the live server. The second extension that I recommend will be Code Runner. You don't really need that one, but I'm going to use this one during the code because Code Runner helps us to run JavaScript code inside of the console. Let me show you. So again, you can just go to the first one right here. Once you typed in Code Runner, now you're going to press install. Once you've installed it, you can now, for example, create an index.js file, so a JavaScript file. You don't need to understand this yet, but just remember this is a JavaScript file. And now we can, for example, write some JavaScript code. You don't need to understand this code yet as well. But now since we have Code Runner, we can right-click the file and press Run Code. And this will execute our JavaScript code inside of the console. But again, for this tutorial, it's not really necessary for you to have Code Runner. I just want to explain this so you understand what is going on. How can we use JavaScript? To use JavaScript instead of HTML, there are three possible ways. The first one would be using the script tag. Usually you use the script tag at the bottom of the body. So let's first of all create the script tag. You have an opening tag and a closing tag. Instead of those tags, you can write JavaScript code. What would be the easiest line of JavaScript code? That one would be, for example, console.log hello guys. You end every single statement in JavaScript by using a semicolon. What does this line right here say? This one says, go to the console and log the statement hello guys, for example. So whatever you have inside of those brackets will be executed and output inside of the console. What is the console? Usually when we talk about the console, we're talking about the browser console. So I can, for example, say that we're going to right-click and open that page with a live server, for example, just to get our updates live. Now you can right-click anywhere on the page and press Inspect. If If you press inspect, you have this HTML overview of your entire document, and you also have this console right here. And as you can see, inside of the console, we are getting hello guys right here. Why are we using the script tag at the bottom of our HTML file? The reason for this is that we want JavaScript code to be executed after our HTML code. Because first of all, you usually want to execute the entire HTML code. So if we have this header, for example, that says npc AO, we want this header to execute first, because maybe instead of our JavaScript code, we want to manipulate this h1 tag. If we would run this script right here, first though, we would try to manipulate this h1, which does not even exist yet because the HTML code has not been executed yet. So it's important to use the script tag at the bottom after you executed all of your HTML code. Now the second option would be to use a script link, for example. So you can also say script, and let's say :module, for example. So right here we have a script of type module and a source attribute right here. So this is similar to CSS. Instead of the source, you need to define a path to an external JavaScript file. So we don't have this JavaScript file yet. So we can, for example, create one by saying index.js. You can use any name right here. You can also say ayo.js, but it's important that the ending is .js, which stands for JavaScript. So let's just use ayo.js to show you that this one works. We're going to link to our ayo.js file instead of the source attribute, which defines the path to our file. Right now, this is the path. Let's go to our website. And as you can see, we don't have anything inside of the console because we don't have any JavaScript code yet. So let's do the same thing again. Let's go to the console and use console.log. npc has no biceps. Let's console.log that one. And as you can see, we are getting npc has no biceps. So this one works as well. Now, the third option is to use the script tag instead of the head. Usually, a lot of people will say that this is something that you should not do because obviously the head will be executed first. And as I said, you should pretty much never execute your JavaScript code before executing your HTML code because you might want to manipulate HTML elements instead of JavaScript. But if those HTML elements have not been rendered yet, you will get a problem and an error. So how does this work? You can define a script tag instead of the head, and I recommend you to use script :module because this defines this as a module. You don't need to know what this is right now, but remember this might be a little bit better. And now again we need to define a source. The source is again ayo.js. So this one looks exactly the same as the previous one, right? And like this it would be pretty bad. So there's one attribute that you definitely need to set if you want to use your script tag instead of the head. And that is the defer attribute. As you can see, this Boolean attribute is set to indicate to a browser that the script is meant to be executed after the document has been parsed. So this means wait for the HTML code to execute, and after the HTML code has been executed, execute the script. And by using this method, you can also embed the script inside of the head. And I usually prefer to keep my script in the head, but remember all of those methods work. So as you saw, you can use the console to output JavaScript code, but there's also a second way, which is the code runner, so the plugin that we've installed previously. So we can just go and click on run code. We'll open a terminal and the JavaScript code will be executed. I will use code runner from time to time because this makes it visually more appealing for you guys. But remember that you can just use this console right here in the browser. There mainly exist three ways to define a variable, and the first one is using the var keyword. So we can, for example, say var followed by the variable name, which could be name, for example, and now we could either end the variable declaration by using a semicolon, or we can directly assign a value to our variable, and we can do so by using the equal sign followed by the value we want to assign to our variable name. So we could, for example, say our name is Pascal, for example. And now we end that statement by using a semicolon. The second way would be to use the let keyword. And now we can, for example, again say let first name, for example, be equal to Jonas in our case. And this would be another option to declare a variable. And the third way would be to use the const keyword. And now we could, for example, say last name equals whatever. So now we have three different ways to declare a variable, but what is the difference between those ways? Using the var keyword was basically the old way And variables defined by using the bar keyword usually have a function scope. We'll get to that later on, and this is something you definitely want to avoid. So from my experience, never ever use bar. So let and const are basically the modern ways to define variables. And the difference between let and const is that let is basically reassignable. So I could, for example, go here and say first name now equals Pascal as well, for example. And this would work. But if I would do the same with our last name, which has a const variable, it should not work and we should get an error. If I say, for example, let's say, hey, and this is our last name now, and now I want to console.log our last name, for example, and I'm going to run the file, you can see that we are now basically getting an error inside of the console. If I go ahead and delete the last name and just log our first name though, and I run the code once again, as you can see, we now get the output inside of the console and everything works just fine. It's also a convention that you use capital letters when you're declaring a constant variable. And a good example for a constant variable would be pi, for example, which is equal to 3.14 whatever. And for variables defined using the let keyword, you usually use camel case, which basically means the first word of a variable uses only lowercase letters, while every other word uses a capital letter as the first letter. And an example would, for example, be camel case. And as you can see, first word only lowercase letters, and the second word starts with a capital letter. And if I would have another word like another word, this is how you would do it. And this is just a convention, so it's good if you just keep that in mind. Let's understand data types in JavaScript. When defining a variable like our first name inside of JavaScript and assigning a value to this first name, we implicitly tell JavaScript that we have a specific data type. And in our case, this data type is a string. So if we are going to console.log the type of our first name, for example, we will see that in our console we now have string. So this one is basically a string. A string is basically just a number of characters, so plain text. To tell JavaScript that this is a string, we are usually using quotes, and you can either use double quotes like this, for example, or you can also use single quotes, and you can also use the backtick character, for example. So all of this basically works to define a string. And a string could be our name, obviously, for example. The second data type would be a number, for example, which is basically, as the name implies, just a number. So we can, for example, say let age be equal to 27, and this would be the data type number. Boolean is basically either true or false, and is mostly used to implement logic. So we can, for example, say let is above 18, for example, be equal to true. Now if we just declare a variable, for example, by saying let hello, and now we use a semicolon, so we don't assign a value, and now we're going to console.log the type of hello, for example, we will now be able to see inside of the console that the data type is undefined. So undefined basically just means that the variable has not yet been defined. But you can also say that our variable hello should be equal to null, which basically means we are explicitly saying that this is an empty value. And now to check whether hello has a value of null, we can use hello equals null. And if this is true, we are going to see true inside of our console. So we're going to run the code, and as you can see, we now have true. If we are going to set this one to undefined, for example, and if we rerun the code, we now get false in the console. So those are the most important primitive data types in JavaScript. Let's understand the Typeof operator in JavaScript. Let's imagine we have a variable like first name, and that first name equals a string of Pascal, for example. And now let's use console.log, and let's imagine we want to know the type of our first name. So let's say we are going to use typeof by writing typeof, and now we are going to use our first name. And by using this statement, we will get the type of our first name variable. If we are running the code now, we will see that we have an output of string. So our first name is basically a string. This could obviously also work if we would have an age like 24, for example, and now we want to know the type of our age, and we are going to run the code again, and now we see that this type of age is basically a number. And this is especially useful when working with if statements, for example, later on, and you want to compare the type of a variable to, for example, another type. Using the plus operator with strings and numbers has a different meaning. Let's imagine we have a first name which is equal to Pascal, for example. Let's say we have a last name, which is equal to whatever, for example. And now we'll use the plus operator inside of a console.log statement by using first name plus last name. What do you think is going to happen if we use an arithmetic operator on strings, for example? Let's just run the file, and as you can see, we now have Pascal whatever. So when using the plus sign with strings, it basically just concatenates both of the strings. And I could, for example, also go ahead and say I want to add another string in between, and I just want to add some tabs, for example. And if I'm going to run the exact same code, you basically see that I added some tabs in between those two words. So you can concatenate as many words as you want. If I use numbers, for example, though, let's say I have a num1, which is equal to 10. And if I use a num2, which is equal to 20, and I'm going to use num1 plus num2, it now does not concatenate those two numbers, but rather just uses addition for those numbers. So when using a plus sign with numbers, use it for addition. When using it with strings, you just use it for concatenation. Let's understand the most important operators in JavaScript. Let's imagine we have num1, which is equal to 5, for example, and we have num2, which is equal to 10, for example. Now we can, for example, create a third number, which is equal to num1 plus num2. And now let's just console.log num3 inside of the console. And once we run our code, you can see that we have 15 inside of the console. Besides addition, we can obviously also use subtraction. And if we run the code, we now get -5. To multiply two numbers, we can use the asterisk symbol. To divide, we can use the division symbol. To get the remainder, we can use the percent sign. And I want to show you how this one works. Let's say we have 15, for example, for the first number, and let's say we have 10, or let's say we have 5 for the second number. Now, if we use this modulo operator, so this percent sign, and we're going to run our code, we'll have 0 inside of our console. Because if you divide 15 by 5, you basically have a remainder of 0. Because 15 divided by 5 works perfectly fine. But if we say 17, for example, divided by 5, we can divide 15 by 5, and this works perfectly fine. But 17 divided by 5 does not really work, and you have a remainder of 2, for example. So this will output the remainder, and I'm going to show you how this works. So we're going to run the code, and now we have a remainder of 2. And now to raise num1 to the power of num2, we're basically going to use the asterisk symbol twice. So now let's save the file and run this code again. And as you can see, we get this number. To make it a little bit easier, let's say we're going to raise the number 3 by the power of 2, and let's run the code, and we get 9. So now let's imagine we just have num1, and we are logging num1 inside of the console. Now to increment num1, we could also go ahead and say num1 is equal to num1 plus 1. And this would obviously increment num1 by 1. And if we're going to log this in a console, we obviously get the value 4 because 3 plus 1 is 4. Now there's also shorter spelling for the exact same thing by going ahead and saying num1 plus plus. And this means exactly the same. And now if we are going ahead and logging this in the console, we again get 4. Obviously, you can also use the decrement operator by using minus minus, and now once we log this in the console, we get 2. There are also different modifications to the assignment operator. So now, as you saw, we can basically say we want to assign a value to our number by using a single equal sign. And this basically means whatever you have at the right will be assigned to the variable at the left. Now there also exists a plus equal sign. So if we are going to say num1 is equal to num1 plus 10, we are basically saying take num1, which is 3, and add 10 to this number. Now there's also a shorter way to say the exact same thing by using plus equal, for example. And now we can, for example, say we just want to add 10. And this basically means as much as num1 is equal to num1 plus 10. And now if we are going to log this in the console, we get 13. Obviously, you can also do minus equals, and this just means take num1 minus 10. So we're going to run the code and we get -7. You can do the same with multiplication and with division, for example. Let's understand escape characters. Let's say, for example, we want to console log text inside of the console. So let's say, hello, this is my story, for example. And as you can see, this works perfectly fine. If I'm going to run this in the console, we get, hello, this is my story. But imagine I wanted to put this into quotes, for example. And as you can see, this doesn't work because I obviously can't use quotes inside of quotes because quotes tell JavaScript that this is a string. And this is basically a syntax that is not allowed. And to get rid of this error, there exist escape characters, which are basically just indicated by using a backslash. So if we use a backslash, for example, as you can see, this right now works. And now we can use another backslash right here, for example, in front of our quotes, and this basically starts to work. And as you can see, once I save the file, VS Code automatically just replaces the double quotes with the single quotes because this would be an alternative. So you can just use the double quotes inside of the single quotes, and if I'm going to run the code, we get this output where we have the quotes. Obviously, this does not just work for quotes. We could also use the escape character on an escape character, for example, because obviously the escape character has a special meaning inside of JavaScript, so you can't usually just use an escape character. So if you want to use an escape character, you have to escape the escape character, basically, if you want to say it like that. And now we basically have one backslash right here next to our this statement. You can obviously also do the same for a new line, for example. So by doing this, so by using this syntax, you can create a new line, as you can see here. And you can obviously also do the same for a tab or a single quote, for example. Let's understand how to work with text. There are several properties and methods you can use when working with strings, and I'm going to show you the most important ones. So let's use a console.log statement, and let's say we want to have the length of our text. So let's use short text.length to access the length property. And now once we save the file and we're going to run the file, we can see that we have 32 characters. So this string basically contains 32 characters. So let's imagine I want to access the first character of a string. And I can do so by using the index notation. So basically by using the bracket notation. So we're going to say that we want to access short text. Now we use the brackets. And now let's say we want to get the first character. And when using JavaScript, counting does not start from 1, but it starts from 0. So our first character has the index of 0. Now we're going to save this and we're going to console.log this. And as you can see, we now have an age. So now let's say we want to have the second character, which has the index of 1. Age is 0, E is 1. So now we should get the character E inside of the console. And as you can see, we get E inside of the console. Now let's say we maybe want to have the S right here. So we are going to start here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and S should be 16. So let's see if this works. We're going to run the code, and as you can see, we're getting an S. So this is basically how counting in JavaScript works, and understanding how counting in JavaScript works is not just important with strings, but with pretty much everything. So just keep that in mind. So let's imagine we wanted to transform this text to uppercase. Then we can just go ahead and use the .toUppercase method by doing so. And every time you access a property, you're just going to write it like this. And if you want to use a method, you're going to use opening and closing brackets. And if you're using VS Code, you'll also get an indication right here if you're going to hover over the property or method, whether this is a property or a method. And as you can see, we have this method indicator right here. So we know for sure that to lowercase, for example, is a method. So let's use to lowercase. And if you hover over the method again, you get an indication right here, which says that this is a method, which tells you, okay, I need to use bracket. As you can see, we now have everything in lowercase, which does not change too much because only our age basically had a capital letter, but yeah. So let's do the exact opposite, and let's say we want to have to uppercase, for example, because right here we should really see a change. We're going to run the code, and as you can see, we now have everything being uppercase. We can also use .includes to check if a substring exists, for example. So let's just go ahead and use .includes, and now we can define the substring we are searching for. So let's see if we have this inside of our short text, for example. We're going to run this and we are getting true because this obviously exists. Now let's say this, for example, we're going to save this, we're going to run the code, and now we're getting false because this with two S's does not exist. The index of method, for example, gives you the index of a certain substring, for example. So let's say we want to get the index of this. We're going to save the file, run the code, and index 5 is basically the index of this because we have 0, 1, 2, 3, 4, and 5. If we want to slice out a part of a string, we can use the slice method by defining a start and an end index, for example. So let's say we want to use slice and we want to get the word this, for example. Then we're going to start at letter 5 and we're going to go up to 6, 7, 8, and let's go to 9 because the last letter is basically excluded while the first letter is included when using the slice method. So let's run the code and we're getting this. Substring is pretty similar to slice. We're going to run the code and as you can see we're getting the exact same result. We can also say that we want to use replace, for example, and we can say we, for example, want to replace this instead of our text with bro, for example. And now we're going to save this and we get, hey bro, is my short text, yup. And obviously this mustn't make too much sense, but as you can see, this kind of works. We can also use the split method to split a string into an array, for example. So we are going to use the split method right here. And let's define a character where we want the split to happen. So let's say every time we have a space bar, we want to have a new item inside of our array. So now let's just save this. Let's run the code and now we have this array which has a new item every time we use a space, for example. So we get an item in our array for 8, for hey, for this, for is, for my, and so on. And you don't need to understand arrays just now, but keep that in mind for later. And now let's imagine we are working with a website and we have a user who puts in like 100 white spaces at the end of our string, for example. And obviously this is nothing we want to save in our database, for example. So what we can do now is we can use the .trim method to trim the text. So basically to remove every white space from the end or from the beginning. So let's save this, let's run the code. And as you can see, we now get this text which should not have any white space in the end. I think it's better to visualize this once we get white space in the beginning. Let's just save this, let's run the code. And as you can see, we have a lot of white space right here. And if we use our .trim method right now, and we're going to run the code again, as you can see, we now removed all of the white space from the beginning. There are a couple of important math functions in JavaScript that you might use from time to time, and I'll show them to you. The first one is math.round. So let's console.log the result, for example, of math.round, and let's say we want to have 1.34. We're going to save this, we will run this code, and as you can see in the console, we're getting 1. So math.round essentially just rounds this number. So for anything below 0.5, it will take the smaller number, and for everything greater or equal to 0.5, it will take the bigger number. If you always wanted to have the smaller number, you could use math.floor instead of math.round. And now we're going to run this code, and now you can see we still have 1. We can also say, let's say 1.4, and now we're going to run math.ceil, and this will always use the bigger number or round up to the bigger number. If you want to determine the minimum or maximum value, you can use math.min, for example. So for math.min, let's for example say we have 1, 2, and maybe 3, and we're going to run this code, and we're getting 1 because that is the minimum number. Now we can also use math.max. We're going to run the code again, and now we're getting 3 because this is the biggest number out of those numbers. Now you can also use math.pow, for example, to raise one number to the power of another. So let's, for example, say 2 to the power of 2, for example. Let's run this code and this should be 4. But, for example, if we would say 2 to the power of 3, for example, then it would be 2 times 2 times 2. So essentially this will be 8. So this works exactly like, normal math. We could also say that we want to get the square root of a certain number. So let's, for example, say we want to get the square root of 16, which should be 4. So we're getting 4 right here. If we want to get the absolute value of a number, so we just want to get the value without a minus or whatever, then we can just say, okay, let's get the absolute value of minus 17, for example, and the absolute value will be 17, because the value of minus 17 is 17. If you just want to get the sign of a certain number, you can use math.sign, for example. Let's run this code, and right here you can see we're getting -1 in the console. Now let's do this, and we're getting 1. So essentially, if you have a negative number using math.sign, you get -1. If you have a positive number, you get 1. And let's also test what is going to happen once we use 0. And as you can see, if we use 0, we get 0. Then we also have math.py to return pi to the user, so you don't have to memorize it or type it out. You can just use math.py like this, run the code, and now we are getting this number. And we can also say we want to get Euler's number, so we can use math.e, for example, run this code again, and now we're getting this number as well. So you don't have to remember pi or Euler's number, and you can just use math.pi or math.e to print out that number, for example, or use it for your calculations if you wanted to. Let's learn about arrays in JavaScript, and there are two ways to define an array. And the first one is to basically just define a variable like fruits, for example, and now we can create an array by using brackets. And imagine an array basically as a list of items, and inside of these lists you can save pretty much whatever you want. We could, for example, say let's have an apple inside of this list, let's also have a banana inside of this list, and let's also have an orange inside of this list. And you separate these items by using a comma. And now let's, for example, say we want to log these fruits inside of the console, and if we run the code we can basically see this is how the array looks like inside of the console. But arrays are basically not just limited to one certain data type. We could also obviously say we want to add some strings in here, but we can also add some numbers, for example, right here. And now we could also add Boolean values if we wanted to. And this in JavaScript works perfectly fine. If you want to access a certain element inside of an array, you can again use the bracket notation. And now let's say we want to access the first element inside of our array. Now we can do so by using the 0, for example. And again, for arrays, similar to strings, counting starts from 0. So our first item is the item with the number 0. Our second item is the item with the number 1, 2, 3, 4, 5, and so on. And now once we save this and run the file, we get apple inside of this list. So let's say we want to have our second item, which is banana. We can do so by using the index 1, and we can access banana. The second method to create an array would, for example, be let sports be equal to new array. So the new array syntax would work exactly the same. And now you use opening and closing brackets. And inside of those brackets, you can also define your items. Now we could, for example, say football, let's say soccer, and 2 items are enough for the demonstration, I'd say. So now let's just log sports inside of the console, and now we get football and soccer, so basically an array as well. And obviously we can access the items the same exact way. You can also create nested arrays. Let's say we want to have a nested array which includes, for example, an array, and inside of this array we want to have more arrays. So let's, for example, say we have an array inside of this array, and the first array includes some numbers, for example, and let's say our second array includes some fruits, for example. And let's have a third array which includes maybe Boolean values. And now we have nested arrays. So we have arrays inside of arrays. And now we can console.log our nested array, for example. And this works perfectly fine. As you can see, if we want to access an item though, we are now going to use a 0 to access the first item inside of our array. And obviously the first item inside of our array is again another array. So we are now going to get this item because this is the first item inside of our first array. So we're going to run the code. We're going to save this, run the code, and now we get this first array as mentioned, which is just the first item inside of our first array. Let's imagine we want to get this first item inside of our nested array though. So now we first have to go to our first item inside of our first array, which is obviously this array. And now we need to access the first item inside of this array. So we can access this item by using brackets twice basically. Now we are going to save this and run the code, and as you can see we now get a 1. So now let's imagine we have a nested array inside of the nested array. So let's say we have arrays in here as well, 1, 2, 3. Now we have another array 4, 5, 6, for example, and we're going to save this. So now we have a nested array inside of a nested array inside of this array. So now we can access our 4, for example, by saying, let's go to the first item inside of our first array, so 0. Let's go to the first item, or to the second item in our case, inside of our array. So we're going to use a 1. And inside of this array, we want to access the first item again. So we use a 0. We're going to save this, run the code, and now we get the 4 as mentioned. And for a lot of beginners, this might be a little bit confusing, but I just recommend you to test it a little bit and you'll definitely get the hang of it. Let's understand the most important methods when working with arrays. So let's imagine we have an array, for example, which is our numbers array, for example, and this numbers array includes numbers from 1 to 5, for example. Now let's say we want to add an item to the end, for example. Let's say we want to add the number 6. So we can go ahead and do so by using numbers.push. So the push method allows you to add an item to the end of an array. So now we can say, for example, we want to add the number 6 to the end. And now we are going to console.log our numbers. And you will see that we now have an array that includes the numbers from 1 to 6 because we added the number 6. Now let's say we added this number 6, but we want to remove it once again because we don't like it. So we can do so by using numbers.pop, for example. And this will just remove the last item of an array. And since we have 1 to 6 right now, and we're going to remove the 6 once again, we should now just have the numbers from 1 to 5. And as you can see, we now have the numbers from 1 to 5. So let's remove our push method, for example, and just run this again. And now we will remove the 5 and we will have the numbers from 1 to 4. Something you should probably remember when using the pop method is that the pop method returns a value. So we can, for example, say let returned number be equal to numbers.pop. And now we can console.log the returned number, and numbers.pop basically takes the number 5, pops it from the array, and now stores it inside of returned numbers. So inside of this variable. So we're going to run our index.js once again, and we now have the number 5 inside of our console because this was the number that we basically took from our array, and now we saved it inside of this variable. The equivalent for pop is basically shift, which removes an item from the start. So in contrast to pop, it does not go to the end of an array, but rather goes to the start of an array and removes an item. So now we should basically get the number 1, remove it from this array and store it inside of returned numbers. So if everything worked, we are going to get 1. And this worked, as you can see. So now let's also go ahead and console.log our numbers, which should now be everything from 2 to 5. And as you can see, this is how it just worked. We can also obviously add an item to the beginning of our array by using the unshift method. So let's go and use unshift. And now let's, for some reason, just say I want to add a basketball to the beginning of our array. So I'm going to do this and run our index.js file. And as you can see, we now have a basketball in the beginning of our array. Let's understand a function inside of JavaScript. Let's imagine you have a console.log statement that allows you to console.log the number 15, for example. And now you have another console.log statement that allows you to log the number 14, for example. And now you just run the script, and this will output the number 15 and 14. Obviously, if you would have a lot more console.log statements, for example, or pretty much anything else, it would get kind of repetitive. And this is where you can use functions. A function basically allows you to execute the same code by using just one line over and over again. So you can define a function by using the function keyword. Now you need to give your function a name, which could, for example, say log in the console, or whatever you want to use. After the name, you use opening and closing brackets where you can add some arguments, and we'll get to this later on. And then you have the body of your function, which is indicated by opening and closing brackets once again. And inside of this body, you can define what you want this function to do basically. So let's say we want to log something inside of the console. So let's remove this console.log statement. And let's say inside of the console, we want to write hello from this function, for example. And now we're going to save this function or this document. And if you're going to run the code, you can see that we're basically not seeing anything. And the reason for this is we just defined the function, but we didn't call the function yet. And if you want to use a function, you always have to call the function. And you can do so by using the exact same name that you defined for the function and writing it out. And then by using opening and closing brackets followed by a semicolon. And now you can save the file, run the code, and as you can see, we now have hello from this function. And now we can obviously also duplicate this function a couple of times. And if we run the file again, you can see that we just executed the code inside of this function block a couple of times. So obviously for this use case, it might seem kind of useless, but imagine we would have a lot more console.log statements in here, for example, or like usually function blocks are a lot more than just this, obviously. But let's say we just have some more console.log statements. And by using this, for example, let's have some different statements right here. And by using a function, we now can create all of those console.log statements just by typing out the name once. And I understand that it might not make too much sense if you just see this example, but especially when your functions get extremely complex, it might save you, or it will save you, a lot of code. So this is why functions are super important in JavaScript and in pretty much every programming language. Another thing that is really useful about functions is that you can define parameters inside of this function. So let's say we want to have a first name as a parameter, for example. And let's say we also want to have a last name. And now inside of this console.log statement, we, for example, want to greet a user. So let's say we're going to use console.log, and now we'll add our first name, for example, followed by a space, for example, and now we'll also add the last name. And now if we are going to save this code and run the code, as you can see, hello undefined, undefined, because we didn't define anything inside of our function. So now if we define a parameter, we should ideally also, inside of our function call, define the arguments that will feed basically those parameters. For example, we could say that the first name is, for example, Jonas, and the last name is, for example, Bro. So now we have a first name and a last name defined as an argument. The function will basically take this argument, put it in here for the first name. So this one will be the first name, and this one will be the last name. And now it's going to console.log hello, first name and last name, because this is what we define inside of our function body. So let's just run this code and we will see hello Jonas Bro. So as you can see, by using parameters, you can define pretty complex logic inside of your function, and this function will now behave different for every input you use for this function. So now we could also greet, for example, someone else. We could, for example, literally greet someone else if we wanted to do so. And now we could run the function once again, and now we are greeting Jonas Bro and someone else. As you can see, by using those parameters, you can make functions extremely flexible. And also, just a short note, when defining the function, you basically call these things parameters, and when calling the function, you basically call these things arguments. So this is just a naming convention, doesn't really matter too much, to be honest, but yeah. Let's understand the return statement. So let's imagine we want to create a function that basically adds two numbers. So we have num1 and we have num2, for example. And inside of this function, we want to add num1 and num2. But if we are going to call this function right now with two numbers like 5 and 10, for example, and we're going to run the code, you will see that nothing is going to happen. So as you can see, literally nothing happened. So how can we change that? Obviously, we could just go ahead and console.log those numbers, but maybe we don't want to console.log those numbers. Maybe we want to store those numbers in a variable. And this is when you can use the return keyword. So you can, for example, say whatever the value of num1 plus num2 basically is, just return this from this function. And now we could, for example, say that we are going to generate a num3, for example, and this one, or a result. And this result basically gets returned whatever this function returns. So let's say we want to have 10 and 10 for this one. So we are going to execute this function. This function takes 10 and 10, basically adds 10 and 10. So we will have 20, and 20 will be returned to our variable. So now we have this result, and now we can, for example, say let's console.log this result to see the result. We're going to execute the code, and as you can see, now we have 20. Since this function now returns something. And returning something is really, really important when working with JavaScript, because obviously you often want to store those values that you generate with a function inside of a variable, for example, or do pretty much anything else with it. Something that is really important to note is if you have like two return statements inside of a function. So let's say we have a third number like num3, for example, and now we also want to return num2 plus num3. And as you can see, this here is already grayed out, because once one return statement inside of a function gets called, the function also stops basically. We are not really there yet, but you'll understand the purpose of having several return statements inside of a function later on. So this is something I just want you to be aware of. So, but yeah, usually once you hit the first return statement, the function basically stops. In some cases, you want to create a default parameter for a function, for example. So imagine we have this greet function, and we are just going to console.log, for example, hello, and then we will, for example, add a first name, like so. So now we obviously also need to accept this first name inside of our function as a parameter. And now we can call this function, so greet, for example, and say Ali, for example. we're going to run this file, and as you can see now, we will see hello Ali, because we are calling this greet function with a value of Ali. But now let's, for example, say we also want to define a default value in case the user does not enter a name. So we can just use the assignment operator and say that our default name should be Jenny, for example, in case the user does not enter anything. So now we can also call the greet method by not using any arguments at all. And this is completely fine right now, since we have a default value, so a fallback value. We are going to run the code, and as you can see, one time we are seeing hello Jenny, and the other time we are saying hello Ali. Since right here we don't have any arguments at all, and right here we defined an argument of Ali. So it's as simple as that. And obviously you could also say the age is, for example, 25 if the user doesn't enter an age. And now you can, for example, say plus you are plus age, for example. We're going to run this again. And as you can see, now we also have an age. Right here, we are defining a function inside of JavaScript. But there's also a shorter way. So let's imagine we want to create a greet variable or a greet function, but we are defining it as a variable. And this greet variable is equal to an arrow function. So let's take a look at the syntax of an arrow function. An arrow function always starts with a pair of parentheses, and you can place your parameters inside of this pair of parentheses. So you can, for example, say we want to accept a first name. Now an arrow function has the name arrow function because you use an arrow right here. Now you again have an opening and a closing pair of parentheses. And this is basically your method body. So right here you can, for example, say console.log, and let's just console.log our first name. You could also write this exact same function by using this function keyword, but you can also use an arrow function. And in a lot of cases, an arrow function might be the more convenient way to do it. And if you wanted to call this function, for example, now you could just do it like a normal function. And let's pass in a first name, for example. And now we're going to run the code, and you should see Pascal in the console. Let's understand the if statement, and the if statement works basically exactly the same as in reality. So imagine if it rains, it's basically rainy, and if it doesn't rain, it is sunny. So you can do the exact same logic inside of JavaScript, for example, by using an if statement. So let's imagine we have a variable that said let rains be equal to true. So right now it's basically raining. And now we can use an if statement to check whether it's raining or not. And if it rains, we do something. And if it doesn't rain, we do something else. And we can do so by using the keyword if, which says that we are going to use an if statement. Then we are going to use opening and closing brackets. And inside of those brackets, we are going to use the condition. And the condition right now is if rains is equal to true. Now we're going to use opening and closing brackets once again, and inside of these brackets we are going to say what we are going to do if it rains. So if rains equals true. And this here is basically the comparison operator, which basically means if the thing on the left is equal to the thing on the right. And if it rains, we are going to console.log it is raining, for example. And now we can also do something that happens if it doesn't rain. So we can use an else statement, and we can, for example, say if it doesn't rain, so else, if rains is not equal to true, we're going to console.log the sun is shining, for example. We're going to save this, and now we can run the file, and you will see right now is raining. So if we set rains to false, for example, so it's not raining, and we're going to run the same code again, we can see the sun is shining. So we are getting this else statement. Let's do another example. Let's say we have an age, for example, and let's say our age is 17, for example. Now, obviously, we maybe want to check if the age is above 18 already. So we can say if age is greater than 18, we're going to console.log you are 18 already. And let's use greater than to check equality as well. And we're going to save this. So if our age is greater or equal to 18, you're already 18. So let's say else our age is you are not 18 yet. And now once we're going to run the code, we will see that you're not 18 yet because we are 17. So if we are going to say that we are 18, we will see that we are 18 already. But let's imagine we also want to check whether our person is between 18 and 50. And we can do so by adding another else if statement. So if you want to check more conditions, you have the option to do so by using else if. And else if works pretty much the same as if. You're going to write else if, so this is the keyword. Now you have opening and closing brackets to add a condition. So first of all, let's check whether our person is less than 18, so he's not 18 yet, then we can say you are not 18 yet. Now let's use the else statement to check whether our age is greater or equal to 18. And we can also say, let's check whether our age is less or equal to 50. And now again, we are going to use opening and closing brackets. And inside of this code block, we can again say, what do we want to do if our person is greater or equal to 18 and our age is less or equal to 50. And then we can basically say we are going to console.log you are between 18 and 50. And else our person is obviously above 50. So we're going to say you are older than 50 years old. And now once we run the code with 17, for example, we get the first code block, you're not 18 yet. Now we're going to say we are 25, for example. We're going to run the code and we see you're between 18 and 50. And now if we say we are basically 51, for example, and we're going to run the code again, you're older than 50 years old. So now this is how you add an if statement, an else if statement, and the else statement. Let's understand comparison operators. And you basically use comparison operators to compare two things. So let's imagine we have a number 1, which is equal to 5, for example, and we have a number 2, or let's say num1, num2, and the second number is equal to 6, for example. And oftentimes you use comparison operators when working with if statements. So if you say, for example, if num1 is equal to num2, we are going to do something like this, for example. But let's just log the result of those operations in the console for now. So let's say we first want to check for equality. So we're going to say num1 equals num2. And now we're going to console.log this, and we see that we are getting false because num1 is 1 and num2 is 5, and num2 is 6. So they are not equal basically. So let's say we have 6 and 6. And now we're going to run the code again, and we're getting true because obviously 6 is equal to 6. Now we can also, instead of 2 equal signs, we can use 3 equal signs, and we're going to run the code and we will get true. So what is the difference between 2 and 3 equal signs? And it's pretty simple, to be honest. 3 equal signs basically means you are checking for strict equality, which includes the value and the data type. So right now those two are basically equal because they have the same data type and the same value, because they're both 6 and both the numbers. So let's imagine we have a string here for number 1 though, and the value of num1 is basically 6 as well, but the data type is obviously a string. So we're going to run the code, and right now we are seeing that we get false in the console because obviously the value is the same but the data type is not the same. So now if we just use 2 equal signs though, we would get true in the console because it does not check for strict equality, it just checks whether the value is the same or not. If you want to check for inequality, you're going to use an exclamation mark before an equal sign, which basically means not equal. So is num1 not equal to num2? And we're going to save this, run the code, and as you can see, this is false because num1 is not equal to num2, if you want to say it. So it's not unequal. So once we basically say that this here is 4, for example, we will get true because those numbers are not the same anymore. Obviously, you can do the same with the double equal sign, for example. If you're, for example, going to say they are the same, but they have a different data type, again, this should be true. But if we remove the quotations and we're going to run the code, this is going to be false because now they are equal. Obviously, there also exists a greater and less than sign and a greater equals and a less equals sign, which most of you basically know from school. So let's assume we want to check whether num1 is greater than num2, then we can do so by doing so. We're going to run the code and we get false because right now num1 is less than num2. We could obviously also do a less than sign, which is going to check whether num1 is less than num2, and this is obviously true. Now we can also use greater or equal to sign. We're going to run the code, and let's say they are equal, for example. Then we're going to run the code and we get true because they are right now just equal. And we can also do less or equal than sign, and this is true again because they are basically equal. And those are the most important comparison operators that you especially use when working with if statements, but basically for all types of things as well in JavaScript. Let's understand logical operators in JavaScript. First of all, let's imagine we have an age that is basically equal to 17, for example. And now you can use logical operators basically everywhere, but oftentimes you use them within an if statement, so we are going to do exactly that. So let's imagine we have an if statement and we want to check whether the age is greater than 18, for example. So we can say if age is greater than 18, but now let's also imagine we want to know whether our person is under the age of 25, for example. And now we can, for example, use an AND operator. So basically using two AND symbols, and this is a logical AND connection. So now we can also say if age is greater than 18 and if age is less or equal than 25, for example. And now we can console.log whatever, for example, doesn't really matter, to be honest. And now once you run the code, and let's say our person is 19, for example, we're going to get whatever, because that's what we just logged inside of the console, if the user is between 18 and 25. And now you could obviously connect as many things as you want to. So you could obviously also say and name equals whatever, but obviously this doesn't make sense in our case. And if you work with logical operators, it's basically just like using normal language. You can just read it like normal language if you write your code in a good way. So if our age is greater than 18 and our age is less than 25 or less than equal than 25. And the same works basically with the OR operator. So instead of AND, we can also say OR, for example. So if our age is greater than 18 or if our age is less than 3, for example, less or equal than 3. So now we can also say, okay, our person is 4, we will basically get nothing in the console. So let's also say now he's 2, for example. Now we're going to run the code and now we get whatever in the console because the person is not older than 18, but he's less or equal than 3. So if you use the AND operator, both of these statements have to be true because you use AND. If you use the OR operator, just one of those statements has to be true. Now you can obviously also use the NOT operator. So let's imagine we are having a variable that is married and that variable is true, for example. So if we want to, for example, check whether our person is married, so is married is equal to true, and instead of this syntax you can also just say if is married. And this would be equal to saying is married is equal to true. So if our person is married, we are going to console.log whatever. And as you can see, we are console.logging whatever. But right now, let's say we want to console.log whatever if our person is not married. And you can do so by using the not operator. So this exclamation mark is the not operator and just reverses the value that is basically there. So obviously if we are checking for a person that is basically not married and we run the code, we are not getting whatever because our person is not married. But once we say our person is not married, so is married is false, and we're going to run the code, we are getting whatever in the console again. Now there are two more operators that are really important and often forgotten, and one of them is the nullish and one of them is the optional operator. So let's imagine we basically have a user. So we are going to create let username be equal to null, for example. And now we are going to console.log our username and we're going to see what we see in the console. And as you can see, we are seeing null. And now you can use the nullish operator to give the fallback value for this username. So if the username is null, for example, let's say he is just called Sven, for example. And now we're going to log the username again. And now we see Sven on the console because if the first value is null or undefined, let's take a look and show you that this works as well. So if the first value is null or undefined, we are basically using Sven as a fallback for the username. And this is especially useful if you work with databases later on and you, for example, have some values where the user does not have to enter a value. So maybe he doesn't have to enter his age. And now if you just have undefined for the age, it's probably not that good for your app. And you want to display an age or say, hey, you didn't enter an age, for example, whatever. Could be a case. And then you have a fallback text that could, for example, say you didn't enter an age, for example, like enter an age, like so. And now you could, for example, say let age be either equal to whatever you get from the database, could be something you enter here. And if it doesn't enter anything, you would obviously get undefined, and then you have this as a fallback text. So this would be a real case scenario. And now let's also say let's username just be equal to null. So we're getting this null value, and now we are going to console.log our username. So now let's say we want to log our username inside of the console. We're going to run the code and we're getting null inside of the console. So now let's say we want to log username.text inside of the console and we're going to log this. And as you can see, we are getting an error because username does not exist. So obviously the property text does also not really exist because username is null and .text doesn't even exist. So now we can use the question mark to check only if the username really exists we're going to look for the text property basically. So let's just run the code again, and as you can see, we're now just getting undefined because we don't have a text property and our username is null. And if you think about a database again, it makes sense if you get a lot of null values, for example, that you first check whether there even exists this property, and if it exists, you can obviously use the value, and if it doesn't exist, you're just going to interrupt the code and return undefined, which obviously makes your code a lot more error prone. Let's understand switch statements in JavaScript. So let's imagine we have this if statement where we basically compare aura to certain values. So if we have 0 aura, we are having 0 aura, otherwise we have little aura, small aura, some aura, big aura, or giant aura, or wait, what? So basically this is the switch statement. I didn't really get a better example, guys, so yeah, you have to take this one. So now we want to replace the same code with a switch statement. So sometimes if you want to compare values to one or another, it makes sense to replace an if statement with a switch statement because this is sometimes a little cleaner. So what we're going to do is we're again going to use switch. And right here we are going to use opening and closing brackets, and we say what value we want to compare to. And in our case, we want to compare to aura. And now we're going to use opening and closing brackets as well. And right here, we can define a case. So let's say we want to use case 0. And if we have case 0, we want to console.log no aura, for example. And then after every statement, you basically want to break out of the loop, because otherwise the code would just keep running and it would execute every single case. And in some cases you might want to do this, but most of the times after you did one of those cases, you want to break out of the loop and just return a value that you had defined inside of this case. So now we can just copy and paste our console.log right here. Let's say little aura, we're going to break out of the loop. And now we can just copy those cases right here couple of times, and now we have case 2, we have case 3, we have case 4, we also have case 5, and now when we have case 1, we're going to log little aura, we are going to log some aura, still some aura, big aura, huge aura, and now similar to an if statement where you can basically use an else block, you can also define a default value right here, and you can say, okay, console.log wait what, if none of those statements basically fit it. So let's take a look, let's run our code, so the index.js, and right now we have huge aura. So let's say we have an aura of 3, for example. Now we still have some aura at least, let's say. And now if we're just going to enter some random values, we should basically just see wait what. So this is basically how an if statement, or how a switch statement works. And now also let me show you how it affects the code if we are going to remove the break statement. So let's say we are going to say we want to have 1 aura or 0 aura, for example. And as you can see, now we have no aura, little aura, some aura, and still some aura in the console, because we are just breaking out of the loop right here. And all of the statements before don't have a break statement, so we are going to console log no aura, and then we're just going to keep going, little aura, some aura, still some aura, and right here we are breaking out of the loop. So you really need this break statement to break out of the loop once you did whatever you wanted to do most of the times. Maybe in some cases this might be what you want, but most of the time I can tell you it's probably not what you want, so you should add a break statement right here. There's a way to write this entire if condition instead of one single line. So first of all, let's say we are going to check the condition by saying sunny. Then we are going to use a question mark, and this question mark essentially says, if this condition equals true, what should I do? And in our case, we want to console.log it is sunny, for example, if this condition equals true. So now we are going to use a colon right after this condition. And after this part, we are saying, what should we do if this condition is false? So if sunny is false. And if it's not sunny, obviously we want to console.log it is not sunny. And now let me run this code. So let me run this index.js. And as you can see, we're getting it is sunny 2 times because we're getting it from this if statement and also from this ternary operator. So a ternary operator, really simple. You have the condition right here. After the question mark, you just define what you want to do if this condition is equal to true. And after this colon, you define what you want to do if this condition is equal to false. So you could also just say 1 equals 1, for example, console.log maybe we want to log 1 if 1 is equal to 1, and maybe we want to log 2 if 1 is not equal to 1. So let's run the code, and as you can see, we're getting 1 because obviously 1 is equal to 1. Let me show you the difference between var and let and const in regards to scope. So let's imagine we have a function. That function has the name greet, for example, and we're just going to console.log greet user. And this variable, if we define a variable that has the name x, for example, and we're going to say x equals 10, and we're going to console.log x, and we're going to call this function, and now we're going to run the code. You can see that we have 10 inside of our console. So this works just as expected, and would also work if we would use let or const. But now let's say that we are going to use an if statement right here, and we say if 5 is equal to 5, for example, which obviously is true, we are going to set var x equals 10. So now we are basically defining our variable inside of this block, inside of this if statement block. We are going to run the code, and as you can see, we are again getting 10, even though we are using our console.log outside of this block. So let's use let, for example, instead of var, and we're going to run the code, and as you can see, we're getting an error. So why is that? So var defines a variable inside of the function scope. So basically inside of the scope of the function where you define it. So even if you go down 10 blocks and define it within an if statement, so within the block of an if statement, you can use it wherever you want inside of the function. While let and const are basically scoped to the block where you defined it, so you can't do this. But if you would go ahead and use the console.log and log it within the block where you defined x using let, you can use it, obviously. And like this it works. But if you get outside of the scope of the block where you defined your variable using let or const, you get an error. If you use let or const, you can just use it within the block where you defined it, so within the scope of the block where you find it. And if you use var, you can use it wherever you want inside of the scope of the function. Let's understand objects in JavaScript. And this is, in my opinion, probably the most important concept that you get in JavaScript, because objects are basically able to represent everything you could represent in the real world. So let's imagine you have a car. Now we're going to define a variable, for example, that has the name car. And similar to a real car in the real world, we can define properties that define how our car behaves, for example. And we can say we are defining an object by using opening and closing brackets like this. Inside of these brackets, we can now define certain properties. So we could, for example, say our car has a certain speed. And now to define properties, we're going to use a name, a property name like speed, for example, and then a colon followed by the value. So our speed could, for example, be 254. Now we could also, for example, define a name for our car. So since I really don't know anything about cars, I'm just going to use whatever, for example. And now let's say this car also has a price. So this price is maybe $19.99. Really realistic, guys, but yeah, as you can see, you can basically say pretty much whatever. You can also say has owner. So does this car already have an owner? And this could, for example, be false. So now you have this car, which could basically represent a real car in the real world, for example. If you are, for example, imagining to code an online store where you sell cars, this could be an object that represents one of the cars you're selling, for example. Obviously, this could also be a t-shirt if you wanted to create a t-shirt right here, whatever. So this is how you create a car. So how can you access the properties of a car? So to do so, let's console.log some of the properties. And there are two main ways to access a property of a car, or to access the property of an object. And the first one is using the dot notation. So I can, for example, say car. So type in the name of the object, which is car in our case, followed by a dot. And now you already see Visual Studio Code gives you all of the properties you've defined. So now we can, for example, access our name. We're going to console.log the name in the constant. As you can see, we get the name of our car right here. So dot notation would be the first way. The second way would be bracket notation. And both of these ways work perfectly fine. So you can just choose whatever you want. So obviously we can use brackets, and then we can just use the property inside of quotes, basically. So we can say we want to access our price. We're going to run the code, and now we get the price inside of the console. So how can I update a certain property? And this works pretty much exactly the same. We can, for example, say car.price is now equal to 29.99. And now we're going to console or run the code once again, and we're going to see in the console we updated the property. And you can obviously also use the bracket notation. So let's say we want to update the price, and now we want to have $199.99. And as you can see, this works exactly the same. To add a new property, you can basically use the same kind of notation once again. So let's say now we want to have an owner name. So the car does not have an owner, but it has an owner name. Makes a lot of sense, but doesn't really matter in this case. Let's say the owner of this car is Jonas, for example. And now we're going to use our owner name, and we're going to console.log it. And now we see we have an owner name. And you can also do the same by using owner name, for example, by using this notation, or let's say owner names, and now we're having Jonas and Vinny, for example, and we're going to run the code, and we don't have an owner name, but we should have owner names. So we're running this, and now we have Jonas and Vinny. So as you can see, you can also add a property by using dot or the bracket notation. So dot and bracket notation works for pretty much everything. How can we delete a property? And in order to do so, you can just use the delete keyword. So you can say delete car.speed, for example. And now let's log speed inside of the console. And as you can see, we get undefined because we just deleted it. And obviously, you can also use the bracket notation if you want to. So this would just result in the same result. Now you can also check whether a property exists. So we could, for example, go ahead, say car.hasOwn property, and now we can name the property, which could be speed, for example. We're going to run the code, and now we see that this is true because we obviously have speed. If we say we want to check whether we have speed 1, we're going to get, whoops, I have to save the file. We're going to get false because we obviously don't have speed 1. So now instead of using hasOwn property, we can also use another syntax, which could be using quotes, using opening and closing quotes, stating the name of the property we are looking for. And now we're looking whether speed is in car. So whether the property speed is in our car object. We're going to save the code and we're getting true. So obviously if we are looking for speed 1, for example, we're getting false because we don't have speed 1. So let's take a look at functions instead of objects. Let's imagine we have this object that is, for example, Jonas, which is just the human being. And this person obviously has, for example, an age of 27 and a name that could be Jonas. So let's say we also want to have a function for Jonas. So how can we create a function? Let's say the function's name is greet, and we can define a function by stating the property name once again, which is greet. So this is the function name. Now we're going to use the function keyword. We're going to define the function right here, and now we can console.log hey bro, for example. And by doing so, we now define the function. As you can see, it works pretty much the same as it works with pretty much every other property as well. So you can just use the property name, and then you define the value, which is in our case a function. So now we can, for example, say jonas.greet. We're going to call the function by using those opening and closing brackets. And now we're going to run our file, and we will see hey bro inside of the console. So this works, but there's also a shorter way to write the exact same. And now let's say wave, for example, is a function that we want to create. We can just go ahead and say wave. Now we can use opening and closing brackets, and then we can just use those brackets again. And then we can just use the method body right here. And inside of this method body, we can say console.log I am waving kid, for example. Now we are saving this, and now we have the exact same functionality without specifically defining a property name. Because right now, I mean, we define a property name, but we did it in another way. And this is the way we basically did it. So now we can also say jonas.wave, for example, call the method again by using opening and closing brackets. And now we can say run code, hey bro, I'm waving kid. And now this is basically the result we are getting. Let's learn about classes in JavaScript. So we already discussed objects. So you can, for example, say you want to create a car, and that car has different properties, for example, like speed, a name, and so on. And maybe you want to have a second car, and that second car has obviously maybe some different properties. Maybe one has a speed of maybe 10 kilometers per hour, and the other one has probably a speed of 100 kilometers per hour. So obviously, if I wanted to create like 10 classes, I would have to write out everything over and over again. And this wouldn't be like really that great, to be honest. So there's an option to basically create a blueprint for an object. And that is a class. So a class basically defines the basic structure of an object. And the object is then the defined class basically. So obviously if you take a look at humans, every human or pretty much all humans are basically the same. Like all of the time they basically have a brain, they most of the time have a body, at least I hope so, and so on. So they have different properties that are common within every single human. But obviously, if you take human A, so for example, if you take Jenny and if you take Max, they probably have a different name, a different age, maybe a different gender, and so on. So they all have in common that they have a gender, that they have a name, and that they have an age. But the age might be different for all of them. So we can basically create the blueprint by using the class, and we can create a class by using the class keyword. And then, for example, we could say person. And you usually use a capital letter when creating a class for the first word. And for every other word, you also use a capital letter. So if I would have person hello, for example, whatever, this doesn't make sense. But yeah, if you would use or would write person hello, for example, then you would use a capital letter for the second word as well, since this is just a convention. So now let's create the blueprint for a person. And inside of this person, we can, for example, say that every single person can greet, for example. So we can create a greet function inside of this class, and we can say console.log hello guys. And now we can, for example, create different persons by saying person1 is equal to new person by writing so. And then we can say, whoops, obviously you need to write it like that. And then we have a person2, for example, that is also equal to new person, for example. And now we can save this and we can run our code, for example, and we have two persons, but nothing is happening. So now we can, for example, say person1 can greet and person2 can also greet. So now we can call this function for person1 and for person2. So the purpose of a class is to basically create a blueprint for objects. So again, let's create a class of type person, and let's say this person can, for example, greet, and if a person is going to greet, we are going to console.log greeting in the console. So now let's create two persons, for example, person1 by using new person to create the person, and let person2 be equal new person as well. So obviously we now have two persons, but those persons are literally completely pretty much the same. So what is the purpose of doing this? Obviously this doesn't make too much sense, but you can use a constructor within a class to create different types of persons if you want to say so. So let me show you. You can create a constructor inside of a class by using the constructor keyword. And inside of this constructor, you can now define several properties that a person should basically have. So we could, for example, say he should have a first name, a last name, an age, maybe muscle mass, and some speed. And now we are going to use opening and closing brackets once again. And when using a constructor, you basically use this syntax. You use this, so this keyword, then the name of the property, first name is equal to first name. Now we are using this dot last name is equal to last name. And I'm going to explain what this means in a second. And this dot age is equal to obviously age. This dot muscle mass is equal to muscle mass, and this dot speed is equal to speed. So what does this mean now exactly? This always refers to the created object. So let me show you, or let me draw it for you. So let's imagine you create a person1 and you create a person2. So now you have this. It's the first person, maybe she's happy, and here you have the second person, and maybe he is not that happy. So now you create one person by using the new person constructor syntax basically, and you create this person. Let's say you create the happy person. So now this refers to this object. So basically refers to the object that you just created. Now you use this line, for example, and create a second person by using new person once again. And now for this object, this refers to this object. So basically to this object. So to the second person. So it's actually really simple. This always refers to this object that you just created. So now we can use those properties. Those constructor properties are basically properties that we can use right here, that we can fill in here. So let's say we have a first name of Jonas, second name of hey or bro. Now we have an age 24, muscle mass 0, and speed 0, for example. So now we have this first person. And now let's create a second person. he has maybe the same last name and has, maybe he's 100 years old, has a muscle mass of 200 kg and a speed of 400 kilometers per hour. Like legit person, but yeah, okay, so whatever. When you define basically your parameters inside of this constructor, those are the parameters that you define or that you use right here. So those are the arguments that you're basically feeding to those parameters. And now those parameters are basically what you have right here at the right. So by using a parameter, you say whatever this dot first name is going to be equal to the parameter that we just used right here. So basically this is the parameter that is here, and you could also have another name. You could, for example, also say this dot name is equal to first name, but by convention you just use the same names. And now if you would create this dot name right here, which is equal to first name, you could also say console.log person1 dot name, for example, and now you can log it in a console and you would have Jonas. So basically those are the properties that you assign to the object, and usually you just use these parameters to give a value to these properties. So I hope this makes sense. Every object has a property and you can use parameters to define specific values for those properties. And now this dot first name basically refers, once you create this first person, this refers to this person. And once you create the second person, there exists basically one this for person 1 and one this for person 2. And this always refers to the object that just has been created using the constructor. So what is the purpose of this? Now you can basically use this inside of the function, for example. So now you could, for example, say console.log this dot first name. And now this for the first person refers to the person 1. So basically to this person, and this for the second person refers obviously to person 2. So now when we go and we are going to use person1 dot greet, for example, we are using the greet function for person 1. This refers to the object that has been created for person 1. So this refers to this object. This object has a name of Jonas, or first name of Jonas, last name of bro, age 24, muscle mass 0, speed 0. So this refers to this object. And now we're going to call for this object, the greet function. And once we go run code, I'm going to save the object, I'm going to run the code. And as you can see, we get Jonas inside of the console. Now, obviously, we can do person2.greet as well. And now for person2, this obviously refers to the object that has been created by using the new person constructor basically for person2 with the values of Pascal, bro, and so on. So we're going to run the code, and now we get Jonas for person 1 and Pascal for person 2. So as you can see, by using this, you can really do a lot of stuff, and it is pretty nice that this always references the object that has just been created using the constructor for exactly this object, basically. And I know it might be a little bit confusing for a lot of you, that's why I really tried to explain it as detailed as possible, but just try it out a little bit and you definitely get an idea what this basically makes. Let's understand getters and setters in JavaScript. So first, let's create a class that is the class person, and this class will have a constructor, and let's say our person has a first name and an age, for example. And now right here we can, for example, say this dot underline first name is equal to first name, and this dot underline age is equal to age. And you're basically always using this underline symbol when you're trying to encapsulate a property, basically. So when you only want to give the possibility to access this property by using a getter and a setter. To some people, getters and setters might seem useless at first, but I'm going to show you the power of them. So if you wanted to create an object, let's say person1, for example, and we're going to create a new person object by saying first name is Jonas and age is maybe 24, we can now say person1 dot first name or dot age is equal to 25. And obviously you could run the code, and now you could also console.log person dot underline age, and if we run the code now, we get 25, even though we set 24 for the age when using the constructor. And now we could also say, okay, our age should probably be -3, and this would be perfectly fine. So now let's use a getter and a setter to basically get and set the property. So a getter, as the name implies, allows you to get the property. So we can use get age, for example. And by doing so, we define a getter for getting the age. Inside of here, we are going to use those brackets, and we are going to use a pair of brackets once again right here. And now we can say that we just want to return this dot underline age, for example. So what this method basically, or this getter basically does, is it allows you to get the age by using the age property from now on. So we can, for example, say console.log person1.age, for example. So as you can see, we are using this property right now instead of underline age. And now if we are logging this in the console, we can see we are now getting the age of -3. So as you can see, this is basically the syntax you use for a getter. You use the keyword get, then you use a name, and this can be any name. You could also say whatever you wanted to. So this would work as well. So this is then the name of the getter. And right here, you basically say you want to return the age of this specific object. So in our case, of this object right here. So now let's also define a setter. And a setter allows you to set the value basically. So let's say we are going to create set, and we're going to say age. And we also want to set the age. But now if we want to set the age, we also need a value to set an age basically. So we're going to accept a value that the user can enter. And right here, we are going to say this dot underline age. So the age of this person basically that we just created using the new person constructor is equal to our value that we just entered here as a parameter. So now we can do so. And now we can, for example, say we want to use person1 dot age. And as you can see, this here is a setter now. So we could obviously use this here as well, but this wouldn't be a good this wouldn't be a good way to do this. So instead of using the property right here, and this underline basically means do not access this property without using a getter or a setter. So basically this is just a convention that tells other developers, please do not touch this property directly, but use getters or setters instead. And in this case, we're going to use obviously the setter to set our age to -3. And if you run the code right now, you see the same result. So it doesn't really change too much, right? And I know at first it might seem pretty useless to a lot of you, but what you can do inside of a setter, for example, is you can do some logic or implement some logic that allows you to validate those values. So we could, for example, say if value is greater or equal to 0, then we can set this.age equal to value. And else we could, for example, console.log not valid, for example. And now if we are just going to run the exact same code, we will get not valid because we basically have an error and our value will still be 24. So a setter and a getter is definitely something that you should implement in your code to basically validate logic and just reduce the risk when writing an application, for example. Imagine you would want to access the keys, the values, or the keys and the values inside of an object. And in JavaScript, there exist methods to do that. So let's take a look at them by console.logging the results of those methods. So let's imagine we just want to get the keys for this entire object. So for this me object that includes the properties name, age, biceps, and IQ. So essentially the keys name, age, biceps, and IQ. We can do so by using object.keys, as the name implies. And then we have to pass the object inside of those brackets. So in our case, it's me. We're going to save this, and now we're going to run the code. And as you can see, we get the keys. So name, age, biceps, and IQ. We can also say that we only want to get the values of this object by using object.values. So we're going to save this, run the code again. And now we only get the values inside of this array. If in case you wanted to get the keys and the values, you can just say that you want to get object.entries. Now we're going to run the code, and as you can see right here, we get nested arrays. So we get an array of arrays, and every nested array contains essentially the key and the value. Let's take a look at the mutability of objects and arrays. So for example, if I wanted to add a property to this user's object, I could just say user.speed, for example, is equal to 100. Now let's console.log our user. And let's run our index.js file. And as you can see, we're getting our new object with a name, an age, and a speed. And the same obviously also goes for fruits. So if I want to say fruits.push, and I'm going to push maybe a monkey to the end of my fruits array, and I'm also going to console.log my fruits, you can see that we are now having a monkey at the end of our array. Even though we used cons for fruits and cons for users, that does not mean that we cannot change the content of those elements. by using, for example, the push method or user.speed or user.property name. So all this really means is that we can now, for example, if we wanted to say fruits is equal to another object or to maybe another array, this here should actually not work. So if I run the code, we're getting an error because I tried to reassign a constant variable, which is not possible in JavaScript. So I cannot reassign the variable, but I can change the content inside of the variable right here. So what if I wanted to prevent the user or myself or other developers from changing the content of an object or of an array? Then I can just go ahead and say object.freeze, for example. And now let's, for example, freeze our fruits. I'm going to save this. And again, I'm going to put this right here. I'm going to clear the console so we can see what's going on. We're going to run the code. And as you can see, we're again getting an error because we are trying to do fruits.push. Since we used object.freeze for our fruits array, it is not possible to mutate this fruits array in any way. So you cannot add content, you cannot reassign the variable, you can't do anything with it besides reading it. So just remember, if you want to make an object or an array immutable, feel free to just use object.freeze. Let me introduce you to the different ways objects and primitive types store data. So let's imagine we have a variable which is a number that is equal to 10. And now we're going to console.log this number 10. And as you can see, we now have 10 inside of the console. Let's create a second variable with the name of y that is equal to x. And now we're going to use y plus equal 10. And now we're going to console.log x, and we have 10 for x. And now we are also going to console.log y, and we will have 20 for y. So x is 10, y is 20. So this would be the normal behavior that you would imagine, right? So how are objects and arrays different? So let's imagine we have an array. Our array is, for example, numbers, and we are just storing some numbers, 1, 2, 3, 4, inside of this array. Now we have numbers 1, for example, and we are just going to set this equal to numbers, for example, and now we are going to console.log numbers, and we're going to console.log numbers, numbers 1, like so. We're going to run it in the console, and now we have the exact same arrays. But now let's just go ahead and say numbers.push, and we're going to push a monkey to the end of our array. We're going to save this, and we're going to run the code, and as you can see, now both of our arrays have monkey at the end, even though we just added the monkey to numbers, and we didn't add it to numbers 1. It would look the exact same if we would use an object, I can tell you that. So how do those different types basically work? Let me show you. So if you have a variable, let's say you have the variable x, and this is basically, imagine it as a package basically. So you take the variable x and put it inside of a package. So now you have a variable y, for example, that you're creating, which is equal to the variable x. So you basically imagine it like that. You take the x, take the value, and put it inside of the variable y, so basically inside of the package y. So you take the value, put it out, put it in there, and now you have the value one time inside of package x and one time inside of package y. So this is how this works. So now we basically have two packages, if you want to think about it like that. But objects and arrays work a little bit different. Let's imagine you have an array, and say this is a package as well. So you have this array, and this array is equal to maybe 1, 2, 3, and 4. And now you just want to duplicate this array. So you have this numbers, you have this numbers variable, and this numbers variable is going to point to the place where you stored those numbers. So basically to an address, if you might think about it like that. And now you want to duplicate the numbers array and create a second numbers array, which is numbers 1. And now instead of copying every single number to a second package, if you want to think about it like that, you're going to take the pointer, and now the second variable is going to point to the exact same address. So you're just pointing to an address, and obviously if you change something inside of this one package, you will change it for every single thing. So let's say we add 5 here. Now you will add the 5 to every single thing that points to the address, because you obviously just have one package and every variable just points to the package. So obviously if you change something inside of the package, every pointer to the package will obviously have the same value now, because it's just pointing to the package, reading the value, and getting this value back to the user. On the other hand, if you have normal primitive types, so strings, numbers, booleans, and so on, you basically duplicate the complete package. with the value inside basically. So now you have basically one package that has the variable x and another package that has the exact same value that has the number y. So if you add 5 to package 1 and 10 to package 2, obviously, you have two different values now inside of those packages. So this is how complex and primitive types work in JavaScript. Let's understand this bind, call, and apply. Let's imagine we are having a user object, and instead of this user object, we're going to greet the user or creating this function. Instead of this greet function, we are going to console.log this, for example. Now, right below, let's say we want to call user.greet and we want to execute the function. We're going to run the code, and inside of the terminal, we see that we're getting back this line of code. So what is really happening right here is that this, in this case, points to the object that has called this function. So this points to this user. What would happen if we would go ahead and copy this function to another variable though? So let's say our copy is going to be equal to user.greet, and now we are going to call our copy as a function. And now if we execute that code, I really recommend you to take a look at this inside of the browser. So if we open our console right here, you can see that we're getting undefined. In contrast, let's call user.greet right here. So we see everything side by side. So one time we get the pointer to our object, and the other time we get undefined. So why do we get undefined right here? By saying that copy is equal to user.greet, we are just saying that our copy is equal to this function. So this will call this function. But at this point, the reference to the user will be lost. So it will not copy the reference to the user. It will just copy the function call. So this would be pretty much similar to creating a function that has the name greet, and then you essentially say that copy is equal to this function. The context in which this function exists in the context of the user gets lost. Now if I wanted to say that this copy should also reference the user or consider the user, so if I wanted to bind this essentially, I can for example say after user.greet that I want to bind this to the user. So I want to bind this copy to the user. I'm going to call copy right here. So let's just execute the code. Let's reload the page. And as you can see, we are getting greet and greet. So for both of those executes, we get the pointer to our object. So now let's get rid of that line right here. And let's also get rid of that line right here. So again, we're just saying instead of our copy, we will copy the user.greet function. So right now we are getting undefined again. So now let's imagine this function right here would have an argument of name, for example. And let's say we're just going to console.log this, and we're also going to console.log our name. So now we need to use a name right here, for example. And now if we're going to log that one, you can see that we're still getting undefined and we're getting the name Pascal. So isn't there a way to immediately just call the copy once, bind whatever object we want to use to this, and then immediately execute that? And there is something like that. So you can say copy.call, for example. So you can use the call function. Right here, you have to define what do you want to bind this to. And in our case, let's say we want to bind to our user. So now we are binding this to the user. We can execute that one. And as you can see, we're getting, again, the pointer to our user for this. And we're getting the name right here. There's also another method to do the exact same thing. And that is copy.apply. Again, what do we want to bind this to? In our case, we want to bind this to our user. And right here, the difference is that you have to apply the arguments by using an array. So we can say Jonas, for example. Going to save that one, going to refresh our index file. And now we have Pascal and Jonas. And again, this is bound to our user object. So if you want to bind something permanently, you can also do it like this by saying .bind user. So now this copy will always be bound to this object right here. If you only want to bind the user one single time when calling the function, you could just use call or apply. So let me show the difference. Let's remove that one again. And if I'm going to call copy afterwards, so after the call and the apply method right here, we will get undefined in the console. Let me refresh. Oops, and we need to remove that. So now let me refresh. And as you can see, we're getting the pointer to our object for those two calls right here. And even if I'm going to say this one has a name, for example, let me refresh, we are still getting undefined and the name. So this here does not seem to point to our object anymore. So bind will always bind, call and apply will only bind for one single call. The while loop and the do while loop are both loops to repeat a certain task a certain amount of times. So imagine you want to do something 10 times, for example. Then you can define a variable, for example, let I be equal to 0. Now we can create a loop by using the while keyword. And inside of this loop, we can, for example, say while I is less than 10, we want to console.log I, for example. And if I would just start this loop would basically run forever because I will never be incremented. This means I will always be 0 and this loop will always keep going and going and going. And this would be an infinite loop. So to break out of this loop at a certain time, we need to increment I every time we run our loop. So I'm going to say right here, we will do I++ to increment I by 1 every time we run this loop. And you really have to think about this loop in the following way. We basically run this loop for the first time. I is equal to 0. We are going to console.log I, and then we will increment I. So in the next iteration, we will check this condition. I is 1, I is still less than 10, so we are going to console.log I, and we will increment I by 1. In the next iteration, I is equal to 2, which is still less than 10. We are going to console.log I, and we will increment I by 1. So we are going to repeat this until I essentially reaches 9. We are going to run this loop again. We will increment I. And for the next iteration, we will check, okay, is 10 less than 10? 10 is not less than 10 because 10 is equal to 10. So at this point, we are breaking out of this loop. And now I'm going to show you how this works. And I'm just going to run the code. And as you can see in the terminal right below, we will now have the numbers from 0 to 9. So essentially all of the numbers that are less than 10. Now there also exists a slight variation. So imagine we're going to put 10 in here. And now we're just going, I'm going to clear the console so we can see the difference. And now I'm going to run the code. And as you can see, we don't have any output. And the reason for this is in the first iteration already, 10 is not less than 10. So this loop will never run. But there's also an alternative, and that is the do while loop. So let's say we're going to have do right here. Now we'll have the body. And inside of this body, we are going to console.log I, and we will also increment I by 1 inside of this loop. So we have the exact same loop. The only difference is that we are starting with the do. And right here, we have the condition after our brackets. And for this condition, let's also say while I is less than 10. So since we have the exact same loop, this loop shouldn't run as well, right? Because I is never less than 10. So let's try this out. And let's also run the code. And as you can see, we get the output of 10. And the reason for this is this loop always starts with the do block. So we are going to execute this block no matter the condition, because essentially this one here comes first. And after we've executed the call block, we are going to check the condition, which is not true in this case. So at this point, we will stop the loop. So the difference between while and the do while loop is that the do while loop will run at least once, while the while loop does not have to run once if the condition never equals true. Another way to repeat a certain task a certain amount of times is a for loop. And a for loop is somehow similar to a while loop, but the syntax is a little bit different. So let's create one. So let's say for, then we need opening and closing brackets, and we create a body similar to the function. Right in here, we need 3 things. The first one is the initial value. Then we need a condition, and then we need to increment our initial value. So let's say our initial value is basically I is equal to 0. Then we need to separate our initial value from the condition by using a semicolon. For the condition, we can say, let's run this loop as long as I is less than 5, for example. So we will run it 5 times, 0, 1, 2, 3, and 4. Again, we have to separate condition from increment by using a semicolon. And for the last one, we say I++. But you can obviously do anything you wanted to do here. So you could also say I plus 2, for example. But in our case, let's increment it by 1 every iteration. And inside of this for loop, we can, for example, say console.log, and we are going to console.log our variable I. Now let's run this file. And as you can see, we repeat this 5 times, 0, 1, 2, 3, and 4. And then we break out of this loop. So a for loop is really, really easy. You just use it to do something a certain amount of times. You define a start value, you define a condition, and you define an increment. Let's imagine we want to output all of the keys of this object, for example. This is really simple by using a for in loop in JavaScript. So we're going to use the for keyword. Now we will define the name that we're going to use for the key. So we can, for example, say let key, but you could also say this can be pretty much anything. But in our case, it makes sense to say that this is the key because it is the key of the object. So let key in, user. So for every iteration, this key holds one of the keys of this object. So let's also create the body. And for every iteration, this for loop now says, iteration 1, this key is equal to this name key for this object. In the second iteration, we take this age key, and in the third iteration, we take the city key. So now let's just console.log our key to show you that this really works. I'm going to run the code again, and right now you can see we get an output of name, age, and city. So to summarize, this iteration loops over an object, for example, and holds one of the keys for every single iteration. So you can essentially use a for in loop to loop over an object, for example. But there's also the for of loop that allows you to conveniently loop over arrays, for example. So let's say we have a const fruits array that is equal to maybe a banana, an apple, and let's say a melon, for example. And now let's use a for of loop to loop over those fruits. So we can say let fruit of fruits. And now let's console.log our fruit, because I think this is the easiest way to really understand it. We're just going to run the code. And as you can see, now for our for in loop, we get the keys of this user object. And by using the for of loop, we get the values or get an output of the values for those fruits. So essentially the for of loop holds the value of one of the items from an array, for example, for every single iteration. So for iteration 1, for example, it goes over this array, takes the first item, so our banana, console.logs our banana, and goes on to iteration 2 since we have a second item. For iteration 2, fruit is equal to apple. It console.logs apple and goes on to the third iteration. And since we only have 3 items, after 3 items, it's going to break out of the loop. And the difference between those two things is essentially that right here, you can, for example, say if you have an object that you want to say, you want to get user of key, for example. And by doing so, you can, for example, also get the value of an object. So let's run this code after I cleared the console. And as you can see, now, for example, we are able to get the value of an object as well. So a for in loop is really good if you want to loop over objects and get key or value of the object, while a for of loop is really good if you just work with an array, for example, and just want to get the value or the individual values of this array, for example. Let's take a look at nested loops. And nested loops are a lot easier than a lot of people think. Let's imagine we have an array, for example, that includes mixed data, for example. It doesn't really matter too much. You can give this whatever name you want. And let's say we have an array, and inside of this array, we have a couple more arrays. So essentially nested arrays. And our first array, for example, includes a couple of numbers. Our second array could include a couple of animals, for example, so a monkey or a zebra. And our third array could include true or false values, for example. So let's say true and false. And now let's say we want to loop over this array. So there are a lot of ways to do it, but let's in our case say we want to use a for of loop, because that would be the way to work with an array. So we're going to say for let array be of mixed data. And now let's just console.log out our array. So we're going to run this code. And now you can see we're getting 1, 2, 3, monkey, zebra, true, and false as separate arrays, as you can see right here. Since we have a nested array, we will also need to use a nested for loop, because in our first iteration, we are looping over this array. So in iteration 1, we get this item right here. In iteration 2, we get this item right here. And in the third iteration, we get this item right here. But if we want to access the items inside of the nested array, so essentially the individual items right here, we obviously have to use another for of loop to get or to loop over the individual items. So inside of our first iteration, for example, we are getting this item right here. So let's create inside of this first iteration another for let value of array. And now we're going to console.log this value. So let me explain this to you again. And I obviously need to use those brackets right here. So this was my bad. So in the first iteration of mixed data, we are getting this array right here. This array contains this array right here. So this array variable contains this array right here in the first iteration. Now, inside of this first iteration, we are again calling a for of loop. And now we are looping over this element right here, because this is the element that we are holding inside of our array variable. So now we say, for every single iteration, one of those values will be equal to this value, or will be stored inside of this value variable. So again, we are in the first iteration for this outer loop, and now for the first iteration of this inner loop, we will store the value 1. So we are going to console.log the value 1. Now we're going to the second iteration, so once we reach the end of this for loop, we're going back to the start of this for loop. So now we have the value 2 for this for loop, and we will print out this value right here. Now we go again to the third value, we take the third value, print it out, we are going back, and now we see, okay, this array is pretty much done, so we are going to finish this for loop. So we are going to go to the next line. We reach the end of this for loop now, so we are going back to the start of this for loop. Now again, let array of mixed data, we're going to get the second array of our mixed data array. We take this array, we go to the next line, we reach this for loop. Again, we start the value of monkey instead of this value, print it, go back to the for loop. We see zebra as the second item, print our zebra, go back, we see, okay, there's no more item inside of this array, so let's keep going. We are going to the end. We see, okay, for loop is over, we are jumping to the beginning again. And this is really how this executes. And I really wanted to explain this properly. I really hope you understood this. I know this can be maybe a little bit confusing for a lot of beginners, but you will definitely get this pretty fast once you're trying to and once you're working with it. Let's imagine you accept the user input and the user inputs this number. So you get this number as a string, but maybe you want to use this number like a real number. But obviously if I would go ahead and, for example, now console.log this number and add hello to this number, for example, and I'm going to run this file, you can see that we are just adding a string to another string. So this is not really how it works. And if I would go ahead and add, for example, a 3 to this number, as you can see, it's like not working at all. So how can I change that? There are two ways to convert this string to a number. The first one would be parse int, for example, and you insert the number inside of these brackets, and now you can run the code, for example, and as you can see, we're getting 6. So parse int turns this string into an integer. So basically a whole number. So 1, 2, 3, 4, whatsoever. But since you can see that this is a float, it might make more sense to turn this one into float. And there also exists a way to do that, and we can just use parse float. Now we're going to run the code again, and as you can see, we now get 6.1423 whatever, because that is essentially the number that this has been converted to. So a floating point number. Imagine we are having an array of numbers from maybe 1, 2, 3, 4, 5 to 6. And now we want to go over this array and do something to every single element, for example. And this is something you can do with the map method, for example. So let's say we're going to create let numbers2 be equal to numbers.map. And this works a little bit like a loop. And right here we are going to use a callback function. So essentially you use an arrow function for that one. So right here, we are going to get a value, and this value in our case is a number. And I'm just going to type this out and explain it in a second. And right here, we are essentially using an arrow function. Our parameter is our number, so we can also write it like this, for example. And now we are just going to return the number, but we're going to double the number. So we're saying number times 2, and obviously this one needs to be numbers1, for example. Or just changed numbers, so it is a little bit more descriptive. So what is a map method essentially doing? So essentially the map method iterates over an array, in our case over the numbers array. It works a little bit like a loop. It takes the first item of our numbers array, puts this number in here, so inside of this placeholder that we've defined here as a parameter, so inside of this number variable, takes this variable, executes this block of code right here, so number times 2, and returns, in our case, the number. Then, again, since this line is executed, it goes to the beginning again, takes a look, what is the second number inside of this array? The second number inside of our array is the 2, so now number is 2. We're going to run this block of code again. We are going to return number times 2, so 2 times 2 equals 4. We are going to return this and go to the next iteration. So this here is always the parameter that holds the value for one iteration and changes during every single iteration. And the nice thing about this map method is that it also returns an array. So if you want to store the values, you can just define another variable to store the array that this numbers.map method, or the map method in general, returns. So what this map method basically returns is an array that looks like this, for example, 6, 8, 10, and 12. So this is basically what this map method in our case will return. And now we can obviously use this changed numbers array again and say we want to console.log it, for example. So we can say console.log change numbers. We're going to run our code and we're getting this output, so the exact same output that I've shown to you. And obviously you're not limited to saying numbers times 2, for example. You can also say you want to do any calculation, for example, or you can actually do whatever you have in mind. So the map method is really, really useful. And especially if you get to React later on, for example, this can be something that you definitely need to know. So I know a lot of beginners underestimate this, but this is, in my opinion, probably the most important method that you really need to learn in JavaScript. In some cases, you might want to filter out some elements of an array. So imagine we have this array and we want to filter, for example, every even number. So we can just go ahead and create another variable and say that one is the filtered numbers variable. And in our case, we are going to say numbers.filter. So the filter method is somewhat like the map method, but it also slightly differs. So what we can do is we can again say we're getting one single number for every iteration. We can again use a narrow function right here, and we can say we want to return the number if the number divided by 2 has a rest of 0. So let's console.log our filtered numbers before I'm really going to explain what is going on there. So let's run this, and as you can see, we are now getting a new array that is equal to 2, 4, and 6. So we're only getting the even numbers. So again, similar to the map method, we have an iteration. During every single iteration, this number holds one of those numbers inside of our original array. So inside of our numbers array, since we are using the filter method on our numbers array. Again, the filter method is a method that you use on an array. So in the first iteration, number is equal to 1. And now we are going to execute this code of block. And we will return our number if our number divided by 2 has a rest of 0. So if number divided by 2 works. For example, 3 divided by 2 is 1 rest 1. If we divide 4 by 2, for example, we get 2 with a rest of 0. So in this case, it works. So every time this statement equals true, we are going to return the number as it is. And if this statement does not equal to true, then we're not going to return the number. So essentially, we are filtering the numbers. So we're taking number 1, putting it in there, executing this line of code. This line of code is false. We're not returning 1. 2, this line is equal to true. We are returning number 2. For 3, this here is false, not returning number 3. 4, this here is true, returning number 4. And this is how it works. So in the end, we are getting the numbers 2, 4, and 6. And obviously, you could put in any logic you wanted to instead of this filter method. So you can define the logic and filter whatever you wanted to. You could also filter an array of strings or an array of objects if you wanted to. So you can define pretty complex logic right here. And this, again, really important if you want to work with React, for example. Imagine we wanted to reduce all of those values to a single value. And in those scenarios, you can use a reduce method for arrays. So let's say const sum, for example, is equal to numbers dot reduce. So we are going to call the reduce method. And this one works a little bit different from the filter and the map method. Again, we need a callback function. So we need to define a function that we're going to execute for every single iteration of this reduce method. So let's say we're going to get an accumulator. So this one essentially always stores the accumulator result. So the intermediate result. Now we will also have a current value, and this current value will essentially change for every single iteration. Obviously the accumulated value will also change for every single iteration, but the current value will always hold one of those values during every single iteration. So iteration 1, it will be 1, iteration 2, it will be 2, iteration 3, it will be 3, and so on. And then we are going to define our callback function, and after this function, so after our method body, we can define an initial value. And in our case, we want to use an initial value of 0. But let's say maybe we want to use 100 as the initial value, so really see what the point of this initial value is. So this is essentially the start value. If we would start from 0 and we would now use or create a sum for all of those values, we would say 0 plus 1 plus 2, so 3, 6, and so on. But since we're going to start at 100, we will say 100 plus 1 plus 2 plus 3, and so on. And obviously you don't have to create a sum, but in our case we're going to create a sum. So we are just going to say that we want to return for every iteration the accumulator plus the current value. So how does this work? First of all, let me console.log the value so we see that this really works. So we are going to run the code, and as you can see, we get 121. So how does this work? The accumulator always has the current value. Since we are starting with 100 for the first iteration, our accumulator holds the value 100, since this is the start value. Now the current value for our first iteration is 1. So this current value holds 1, and now we have 100 plus 1. Since 100 is the starting value, so the accumulator value, and our current value is 1. So we are getting 101, ending the first iteration and going on to the second iteration. Second iteration, accumulator is 101, and our current value is 2. So again, we are going to say 101 plus 2 is equal to 103. We're going to store 103 inside of our accumulator and going on to the next iteration where we say, okay, current value is 3 right now. So we're doing again the exact same logic for every single one of those elements. So 3, 4, 5, 6, and then we're ending up with that sum. So we can also obviously say for the starting value, and that's probably the common way, that we're just going to use 0, and now we can console log this again and we're just getting 21. So yeah, makes sense, I would say. So imagine you also want to add a couple of parameters in the end, but you don't really know how many parameters you want to add, or it's up to the user how many parameters he wants to add. So in that case, we can, for example, say that we're going to use the rest operator. So for example, we can just use a comma followed by dot, dot, dot. And let's, for example, say right here, the user is able to enter some numbers, for example. And let's say we're just going to say console.log, and we will just log our numbers. And right here after Ali, for example, we can now say 1, 2, 3, 4, or 100, for example. And now we're going to run this code. And as you can see, we are now getting hello Ali, and we're also logging those numbers in the console. So obviously you're not limited to logging the numbers. You could also use a reduce method on those numbers. So you could, for example, say numbers.reduce, for example. And in our case, we are having an accumulator, we are having a current value, and we are going to say we will just return accumulator plus current value, and we're going to start with the value of 0. And let's just say we're just going to console.log this one here. We're going to save this, and now we're going to run the code again. And as you can see, we are now getting 110, since obviously 100 plus 4 plus 3 plus 2 plus 1 is 110. So as you can see, you can also do pretty complex logic if you wanted to with these rest parameters, and this is obviously up to you. In some cases, you might want to spread the properties from one element to another. So let's imagine we, for example, want to create a new user. So we can, for example, say const new user is equal. We are again going to create an object, and right here we are saying dot, dot, dot. So this is the spread operator syntax. And now we're going to say dot, dot, dot followed by user, because we want to spread all of the properties of our user into our new user. And now we also want to add an age, for example, of let's say 25. We're going to save this, and we're going to console.log our new user. So you really see what's going on right here. I clear the console, and let's run this file. And as you can see, now we have a new user with the name of Ali and an age of 25. So what is exactly going on? This spread operator basically just says, take whatever you have right here, spread it right here. So take all of the properties out and put it in here. And that's essentially it. And you can also use the spread operator for arrays, for example. So we can say const new numbers is equal to another array. And now we again want to have or extract all of the values. So spread all of the values of this array inside of our new arrays. So we can, for example, just say dot, dot, dot numbers, for example. And now let's also add 4 and 5 and 6 instead of this array. And now we're going to log console.log new numbers. We're going to save this and run the code. And as you can see, now we're getting this new array that includes all of the numbers of this other array, so of our numbers array, and the new numbers that we've added. So you can also use the spread operator to clone something. Now we're essentially saying we have this array, take the values of this array, and spread those values into this new numbers array. So we're going to run the code. And as you can see, now we're just getting 1, 2, 3. And this is a really good way to copy the values of one array or one object to another object or array. Oftentimes, when you work with a database, you get values like those ones, for example. So you get an object that has, for example, a name, an age, an email, username, password, whatsoever. So imagine this is an object that we're getting from the database. But now maybe we don't want to work with the entire array all of the time. Maybe we want to extract the username, we want to use the email and so on. And there is a way to destructure the properties from this object. And it is really, really simple. You're just going to say const or let whatever you want. And then you're going to use those brackets if you want to destructure an object. And right here, you just have to define the names of the object that you want to destructure. So let's say I want to get the name. Then the key of our name property is obviously name. So I can say I want to get the name. Then I also want to get the age, for example. And maybe I also want to get the email. And now I destructured the properties of this object by saying equals user. So now I'm saying essentially get me the property name, age, and email as a variable from the object user. So now let me show you that this really works. So now we can console.log our name, for example, or let's say name, since this is a predefined name inside of JavaScript, we cannot use name like that. So we can, for example, say name, first name. So we are renaming our name to first name. So we're going to say console.log first name. We're going to run this file. And now we're getting Ali inside of the console. Now you can also say console.log age. And now we should log our first name and our age. And as you can see, we're logging name and age. So essentially, by using this syntax, you are extracting the properties. And by using a colon followed by another name, you can rename the property if you wanted to. But you can also destructure arrays, for example. So you could, for example, say const num1, num2, num3 is equal to numbers. So this syntax essentially says, take the first value and save it to a variable with the name num1, take the second variable, put it into num2, and the third variable and put it into num3. And to show you that this also works, let me console.log num1 and num2. We're going to run the code, and as you can see, we get 1 and we get 2. In JavaScript, you oftentimes have code that could throw an error. If you think about fetching data, for example, and you're talking to an API, you're getting some data right here by using the fetch request, it is likely that this fetch request will reply with some data, for example. But it's also possible that the server is down, for example, or the user does not have internet or anything else. And then you will have a problem. And if you don't use a try-catch block for that one, your program will terminate if this one throws an error. So you have to put this one into a try-catch block so that your program does not terminate, but instead does proper error handling. So let me show you how this works. So let's say we are having a try right here. So whatever is in this block will be tried. So this could be a fetch request, for example, and oftentimes this is something like this. But in our case, let's just say we're having a variable that is equal to x, and we're going to say that one is equal to 5. And now we'll also have a catch block. If we get an error, we are having an error argument right here. And then we can, for example, say that we just want to console.log our error. So let's also go ahead and say console.log, and we're going to console.log x. But let's say this one here is x being equal to 5, and this will not throw an error. So we will see 5 in the console. But now let's, for example, say that we're going to use strict. And by using strict, this would throw an error. So we're going to run the code. And as you can see, we're now getting an error. But this time, this error message is not the one that we are getting previously, but it's the one that we're logging right here in the console. And you will see that this is true if I'm just going to say an error occurred, for example. So we're just going to log this in the console. We're going to run the code again. And as you can see, now we only get the message, an error occurred. So we caught this error right here and had a console.log statement. And now you could also have a finally block after your try catch block if you wanted to. So you can say finally, for example. And this block will always be executed, no matter whether this is a success or an error. So we can say console.log I will always be called. We're going to save that one. We're going to run the code. And now we get an error occurred, I will always be called. Also, if this here is let x being equal to 5, and I'm going to run the code, you will get 5, and I will always be called. So whatever you want to try comes into the try block. If you get an error, you're going to catch that one here. And if you want to do something, no matter success or an error, you're going to use the finally block. Let's understand JSON, so JavaScript object notation. If you have this user, for example, and you're having a database, so you have your website right here, and you have a database, for example, right here. If your website talks to a database, there also needs to be a language for talking to the database, because the database does not understand this plain object. And the language that your website and the server use to talk to each other is going to be JSON, so JavaScript Object Notation. So let me show you how this user looks instead of JSON. To create a JSON file, you're going to say index.json, for example. So you have the .json ending, and instead of JSON, you will have opening and closing brackets. Now you will have a username, but you have to have the key inside of quotation marks, like this. Now again, you have a colon, and right after you have the value, which can be Goku, for example. For our next key, we would have our age, for example. So we can again say age. Age is equal to 24. Now we have a biceps size, which is equal to 12 centimeters. And we are also going to have a boolean of has brain. So has brain, and that one is equal to false. And as you can see, this really looks like a normal object. The only difference is that this is JSON. And the difference between JSON and normal objects is also pretty easy. You just use those quotation marks right here for the keys, which you would not have to use for an object. And the rest stays pretty much the same. And if you talk to a database, so if you send this data, you're going to take this object, you will turn this into JSON data, and then you will send it to the server. If you get it back from the server will send you this JSON object. You can then parse this JSON object the way we've done it previously by, for example, using json.parse, and then you can use it as a normal object again. Let's understand callbacks in JavaScript. Imagine we are having a function that says, for example, greet, and essentially just does something. And we're going to pass a callback to this greet function. So we'll say that right here, we will pass a callback. This here is going to be a function that we'll define later on. And we are just going to execute this callback right here. And we will pass two arguments. We will say Pascal, for example, or let's just use one argument for this simple demo. And we are just going to call this callback with the argument Pascal. So we don't have this function yet. So what we're going to do is we're going to define this function. So we will say function, say hello, for example. We will accept a name right here. This name will be Pascal later on, as you see. And now we are going to say console.log name. So we're just going to console.log our name instead of this callback function, because that function is essentially what we are going to use for our callback right here. This callback will later on be called right here, and we will pass this argument as a parameter to this callback function. So now we're going to say we're going to call greet, and as an argument, we have to insert a callback function, which is say hello in our case. We're going to end that line, and now we're going to run the code. And as you can see, we're getting Pascal in the console. So a callback function is essentially just a function that you call within another function. And if you think about an array of numbers, for example, where you just have a couple of numbers inside of the array, and you're going to loop over those numbers by using the map method, right here you can also see that we're having a callback function. So we are passing a function right here. We are getting one of those numbers every time we loop over those numbers, and then we're going to execute some form of code. So even if you're not going to use callbacks the way I showed it to you, you will oftentimes use callback functions the way we're seeing it right here. So it's important to understand that this right here, for example, is a callback function that will be called back several times by this map function right here. Let's understand promises in JavaScript. So imagine we're going to have a promise that we will create, which is equal to new promise. So we're going to create a new promise object. This promise object will have a callback function that accepts two parameters. One of them is resolve and the other one is reject. We're going to use an error function right here. And let's define a variable that has the name success that is going to be equal to true. And we're going to say if success, so if success is equal to true, then we're going to resolve this one and we're going to say it worked. Otherwise, we're going to say that we're going to reject and it did not work. So now we have a promise. If we have success right here, we're going to resolve the promise. Otherwise, we're going to reject the promise. And this is obviously a very, very simple case. In reality, you usually use promises to fetch data, for example. So now we just created this promise, but we're not really using it right now. So we need to use it. So we can use a promise by saying promise, in our case, dot. Then we can call the then block. the then block will be executed if the promise will be resolved. So let's call that one. Right here, we again need a function. We're going to get a result. The result is what we're getting back from this result function. And now let's just say console.log, and we're going to console.log the result. Now we can also add a catch block right here. So we're essentially chaining methods right here. And inside of the catch block, it's a pretty similar procedure. The difference is that we're not getting a result right here, but we're getting an error right here. And obviously the names are up to you. You could also say that this is a result as well, but the convention is that you call this one error because it's more like an error. And we're just getting this text right here if we're getting an error. So we can also just say console.log, and let's just console.log the error. We're going to save that one. We're going to run the code. And as you can see, we're getting it worked because success is true right now. But this one can also be false. So we're going to run this one again. And now it did not work, because success is equal to false. So a promise is just something that says, I will promise you that in the future you will get a result, and once you get this result, I'm going to get back to you. And I'm either going to resolve the promise and get you the result, or I'm going to reject the promise and I'm going to give you an error message. So last time we took a look at a promise. But why is a promise even useful? And a promise is really useful because you can do a lot of things, especially when working with APIs. So an API is an application programming interface. But what is an application programming interface? So imagine someone, for example, has a lot of data about the weather. So I can make this data available for pretty much everyone who wants to use that data. So if you're having an app, for example, so let's say you're creating this website right here, and you want to use this weather data, then you can talk to this API that maybe someone else has created, or you have created this API, doesn't really matter. And you can say, hey, give me that weather data, for example. Then the API is going to respond, and this API will give you the weather data. So you do a request and you're getting the data. So a response essentially. So request and response. So this is the request and this is the response. Even though this looks, pretty weird. And in the internet, there exists millions or billions of APIs. So maybe someone has an API for weather. Someone might have an API that includes all of the bicep sizes of bodybuilders, what a drawing. And then you can get the bicep sizes of bodybuilders, for example. And then you could display those values on your website, for example, like so. And that is the purpose of an API. So I think now you can guess that an API is really, really useful. It can also be pretty useless, and I'll show you a pretty useless API. So we can, for example, search for a random user generator right here. And as you can see, we have this random user generator URL right here. So we can click on this one. And as you can see, we have instructions on how to use this API. And usually when using an API, you get something like a link like this. And you don't have to use this link instead of JavaScript. You can also just say that you're going to paste that link in here. We're going to do this call to the API. And as you can see, we called the API by using this link. And now we're getting back data from the API. So essentially, we're having this results right here that includes a gender, the gender is female, a name, a title, and so on. So we're getting a lot of data by calling this API. And now we can use this data. In our case, the data is completely useless, but sometimes you might maybe want to get useful data like muscle sizes. So how can we get this data inside of JavaScript now? We can use the fetch method right here. We can say that we want to use our URL right here in a pair of strings. And now this returns a promise. So this promise that we've used previously. So once we get the promise, we can use .then. We are going to get a response. And let's say we are just going to console.log our response. And we can also use catch. We're going to get an error, and we can just console.log an error. So let's save that one. We're going to run the code. And as you can see, we're getting this object right here, which looks absolutely terrible. And the reason for this is that the response object does not really make too much sense because it includes JSON data, and you want to get this JSON data. So in order to get the data, we're going to say response.json. And most of the time when you work with an API, you get JSON data, you want to get this JSON data, so you use this type of syntax. But the point is that response.json, so this method essentially returns another promise. So now we have to use a chain of then methods. So we again have to call then right here, and we only need one point, like so. And in here, we're getting the data. So we can say data, and now let's just console.log our data. we're going to clear our console and let's run our index.js file. And as you can see, now we're getting the data object. And as you can see, we're getting the results field, for example, instead of our data. So maybe we want to get our gender. So first of all, let's log data.results, for example, because this is an object that has the results property, so we can log that one. We're going to clear the console and we're just going to run our file again. As you can see, now we are inside of our results object that again has the gender, for example. So we can say data.results.gender. By doing so, we are going to access the gender property right here. We're going to run the code. And the reason for this not working is that this here is essentially an array. So we're going to access the first element of this array, which is this object. We're going to run that. And now you can see that we're getting male as an output. But obviously this here looks absolutely terrible. So I recommend you to usually just create an index.html file. Then you create a basic template and then you're just going to link your script tag inside of this file right here. So inside of the index file, you're going to open that one with a live server. And now inside of this live server, you can also inspect everything. And right here, you also get the output of female in this case. And now, for example, you could just say, okay, let's log the data right here. And it's a lot better to see the data inside of the console right here compared to the console right here. But that is like just a personal preference. So right here, you can, for example, see the result has info, results, and so on. So you could also access the info, for example. And also I want to say that what you're getting right here is just a normal object. So if you work with that object, it works the normal way. You can access properties by using the dot notation, for example. So if you want to get the info, for example, which is a normal property of this object that you're getting, by converting this JSON data right here to an object, so to this data object. And inside of this data object, you can now access the individual properties right here just by using a normal dot notation, the way you would do it usually when working with objects. So you can, for example, say this object right here has the info property. So you could access this info property by saying data.info. We're going to refresh the page. And as you can see, now we're accessing the info. The info, again, is another object. So it's a nested object. It's an object inside of an object. So if you want to access the seed right here now, again, inside of this data object, inside of this info object, you just have to access the seed property by using the dot notation. You can reload, and you could just say that this here is the seed. And you don't need to use the dot notation. You can also use the bracket notation, but I prefer the dot notation usually, and I think most people do. But I just want to show you, this is just normal work with objects, and these objects that you're getting by using a promise are not different from objects that you're creating yourself when working with JavaScript. So also, every time you call an API, you're fetching data again. And since we're just getting a random user every time we call this API, you will see that we will get a different URL right here, or different seed right here every time we call our server. And we would also get a different gender, a different name every time we call or fetch data from this API. Obviously, if you have something like better data, it shouldn't change too often, I would say. Instead of using a promise, you can also use the modern syntax of async and await. So let's say we are going to create a function that is responsible for fetching data. And instead of this function, we are going to fetch the data. What kind of data are we going to fetch? Let's say we're also going to fetch the random user data. So now we have this API right here. And let's say we want to call the exact same API, which will generate a random user. But if you use the modern syntax of async and await, you need to declare a function as async. By using the async keyword in front of the function keyword, you say this function will be async. Every time you use a fetch, for example, to fetch data from an API, the call is obviously asynchronous. So it takes some time to complete the call. Because if you communicate with an API, you send a request. This request will, for example, be transmitted via your LAN cable or via the air, depending on what kind of device you use. But no matter what you use, transporting this signal takes some time. So you send the signal, request data from the server sends the signal back, and this takes some time again. So in total, you have to wait a little bit until you get a response. The time is not that long, but you have to wait some time. And that is the point. So once you get to this line and you want to fetch the data, it might take a couple of milliseconds, seconds, whatsoever to get the response from this fetch request. So we need to await the response. So by using await, we are saying we have to wait for this response until we can get the data. And now we can say that we want to get the data and store the data instead of this result. So we can say const result is equal to this fetch request. And now let's just console.log this result right here. Now let's also call this function. And now let's run this code right here. And as you can see, we're again getting the entire result. Let's also now delete this data right here. And let's take a look at this inside of our index.html file. So we're getting this response right here. This response again concludes JSON data. So we need to say const data is again equal to result.json because this is JSON data. And as I've said previously, this one here returns a promise as well. So we need to await that one as well. And once we get the data, we can, for example, say that we want to console.log our data. So let's refresh the page. And now we're getting this data. And now we could, for example, access our info.seed if we wanted to, the way we did it before. So info.seed, going to save that one, going to reload the page. And as you can see, we're now getting the seed right here. So this right here is the alternative to using a promise to fetch data, for example. And every time you do something that takes some time, so every time you do something that is asynchronous, you can use async combined with await. Let's understand the strict mode in JavaScript. Imagine we are having a variable x that is equal to 5. And now let's console.log our variable x. We're going to run the code. And as you can see, we're getting 5 in the console. So even though this is not the perfect way to write that statement, we are not getting an error, because usually we should have a let or a const keyword here. A var keyword is not the recommended way, but would be better than not having anything right here. So how can we prevent this behavior? We can activate strict mode by saying that we want to use strict. We're going to enter statement. We're going to run this code. And as you can see, now we're getting an error. So what strict mode does, it says, be really strict about my syntax. And every time I do something that is not perfect, throw an error. And I know to a lot of you this might seem like something that is unnecessary or tedious, but using strict mode can definitely prevent a lot of errors and can help you to write cleaner code. Let's understand the call stack and the event loop. So imagine we are going to have a couple of console.log statements. So 1, 2, 3, and maybe 4. And we're going to end each of these statements by using a semicolon. And now we are going to run the code. And as you can see, we're seeing 1 first, then second, then third, then fourth. So how does all of this work? So JavaScript is only using one thread. And this means that it is executing the statements sequentially. And it can't execute two things at the same time. It can always only execute one single thing. So it executes this line, goes to the next line, executes this line, goes to the next line, executes this line, goes to the next line. So it does not execute those lines parallel, but one after another. So now let's imagine we're going to have a call right here of set timeout. We're going to wait until a certain time is over, and then we're going to console.log the number 5, for example. And let's say for a timeout, we're going to use 1000 milliseconds, so 1 second. Let's run the code again. And as you can see, we're getting 1, 2, 3, 4, and 5. So even though this line is the third line, it will be executed last. And what is happening here is that JavaScript will execute this code sequentially. But if you have something that could block the code, like a set timeout function, for example, that would block the entire thread for a second, JavaScript will usually pass this task to something else. If you work with a browser, for example, it will give this task to the browser, and the browser will get back to JavaScript once the second is essentially over and say, okay, now you can execute the code. And if you don't work with the browser, it is usually Node.js, for example, that is responsible for doing this. But if you're working with HTML, CSS, and so on, it's the browser. And this is really important because otherwise this line would block the entire code afterwards. And that would obviously be a terrible user experience if you imagine you have like 10 seconds here, for example, and then you would have to wait for 10 seconds to execute the rest of your code. Let's understand scope chain and closure. Let's say we have a function that has the name print, for example, and instead of this function, we have the value set, for example, which can be equal to, let's say, 5, for example. Now let's also say instead of this function, we define another function that can be print2, for example. The name doesn't really matter too much. And we're just going to define set once again. So we say this time set is going to be equal to 6. And now let's say console.log, let's log z right here, and we're going to call print2 inside of this function. Now we are going to call print right here, and we're going to run the code. And as you can see, we're getting 6 in the console. And the reason for this is scope chain. So as you know, usually a variable exists within the scope of a function. So in this case, everything right here belongs to the scope of this function, so of the outer function print. And everything right here belongs to the scope of the inner function print2. So now when we want to access the variable set, it works like this. It first takes a look within its own scope and checks whether it has a variable set. If it has a variable set, it is going to use that variable set. If it does not have a variable set, for example, it is going to go one level up and it is going to look here for a variable set. If it has the variable set, it is going to use this variable set. As you can see, now we have 5. If it does not have a variable set, it is going to go one level up. And let's say we have a variable set of 3 right here. We're going to run the code. And if it finds the variable set right here, it will use that one and it's going to print it out. So right here we have 3. Otherwise, it did not find the variable and we're getting an error. So when accessing a variable, it starts from inner to outer. Now let's take a look at closure. So let's say we are going to have a function that has the name outer, for example. And inside of this function, we define a variable. So let count be equal to 0, for example. And inside of this function, we will return another function. So let's say this here's the function inner, for example. And this function just says count plus plus, so increments the count by 1. And we need the function keyword right here. And now we're also going to console.log the count. So now let's say we are going to have const counter, which is equal to outer, like that. And now let's say we're going to call counter, and we're going to call counter once again. Let's run the code. And as you can see, we're getting 1 and we're getting 2. So somehow this inner function, so this function is able to keep track of the count, even though we've defined the count instead of the outer variable. And what is happening here is called closure. So every time you return a function inside of another function, this inner function is able to keep track of the variables defined in the outer function. And I know this can be confusing, and I'm also going to be honest, you barely ever need this. So it's cool if you have heard of it, but it's very unlikely that you need this. Let's understand hoisting and temporal dead zones. Let's imagine we are having a function that could be, say, hi, for example, and instead of the function body, we are going to say that we'll console.log hello, for example. Now, what will happen if we are going to call this function, say hi, right before we declare this function? Let's just try this. We're going to run the code and we're getting hello instead of the console. So this actually seems to work. And the reason for this is hoisting. When you define a function like this, the JavaScript compiler will take this function, place it at the beginning of the file, and execute the code like this. So no matter in what order you define the functions and call them, the function definition will always be hoisted to the top. But what about variables? Let's imagine we're going to console.log a variable x, for example, and we are going to define this variable x and set it to the value of 5. Now let's run this code again. And we're getting undefined. So why are we getting undefined? The reason is that for the variable declared by using the var keyword, the JavaScript compiler is only going to take this var x definition, will put it right here, and afterwards it will assign the value to the variable x right here. So it's only going to hoist the declaration or the initialization of the variable x, but it will not hoist the assignment to the variable x. What would happen if we would use let or const, for example, instead of var? So let's run the code. And as you can see, we're getting an error. Now you might think that the variable x will not get hoisted if you use let and const. And somehow you can think about it like that. But what is really happening, that the variable x will be hoisted right here. And the assignment will happen later on. But from this point on to this point on, we have a temporal dead block when we're using let or const. So this essentially means you cannot access that variable before its assignment. But to be honest, I know a lot of people say that this is super important, but in my opinion, it's not really that important. All you have to think about is that you should essentially, when working with JavaScript, define your variables at the top and also assign the value at the top. And while it might not really make a difference whether you define your functions before or after calling them, it's definitely best practice to define the functions before calling them. So if you stick to the conventions, you should definitely not have any problems anyways. So you probably know how to create a function like this. But as you can see, this is a really inconvenient way to add variables and strings together. And imagine you would have maybe another string, for example, and then you have another variable, and you always have to say plus, 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 and you probably don't want to do that. So there's also a better method inside of JavaScript to get the exact same result. So let's use backtick characters like this. And inside of these backtick characters, we can say hello, for example. Then we are going to use a $sign followed by these kind of brackets, and inside of these brackets you can now define or can now use JavaScript variables, like first name, for example. Now you could also go ahead after those brackets and say you are, and now let's say we also want to get an age of the user, age for example, and now we can again use a $sign followed by brackets, age, years old. And as you can see, it's a lot easier, especially if you want to concatenate a lot of variables, to use this kind of syntax. So now let's just greet the user in the console. Let's say we have Jonas, for example, and he is probably 1 year old. And we are going to run the code. And as you can see, hello Jonas, you're 1 year old. Or 1 year old, probably not the best idea, but yeah, as you can see, the logic definitely works. Let's understand modules in JavaScript. First of all, if you use index.html to link your JavaScript file, you will have to say that this script tag has a type module to really declare this as a module. And if you want to have the shortcut, this is pretty simple. You're just going to say script:module. So you automatically define this one as a module, and then you can link your index.js file. And we also need the def attribute here to say this one will be parsed after the entire HTML code. Now inside of our index.js file, this one here is now declared as a module, so we can use this one as a module. So imagine we want to have a function and we want to get this function from another file, for example. So let's say this are helper functions, for example. So this one is the helper.js file. And this one just declares a function that says, say hello, for example, and it's just going to console.log hello in the console. So this is pretty simple. But now we want to use this function inside of this file, for example. So how can we do it? Can we, for example, say import helper? This does not seem to work. So we have to export this function from our helper.js to use it inside of our index.js. To export a function, we can say export function, say hello. Now this function is being exported, and now we can import, say hello from helper. And as you can see, this is the syntax. So you have opening and closing brackets. Then you have the function name inside. You're going to say from what kind of space do you want to import that one? We want to import that one from ./helper. And I recommend to say .js right here. Otherwise, I oftentimes get bugs. And then you can use this function right here. So you can now, for example, say hello. You can call the function right here. So if I'm running this code, you say we're getting an error. And the reason is that I'm executing that one using Node.js, as you can see. And Node.js does not really see that this here is declared as a module by using HTML. So I have to execute this code inside of HTML. I'm going to reload the page, and right here you can see that we're getting hello. So this seems to work. So we have now used this function instead of our index.js file that has been exported from our helper.js file. And now we could also export a lot of functions inside of this file. So we could also say goodbye. That function is just going to console.log bye, for example. It doesn't really matter too much. And now we can also say we want to export that function right here. And now we can say goodbye, for example. We also want to call that function. We want to execute that function right here. And this now works as well. So now we're getting hello and bye. So this works. But now we can also export something as a default. So we could, instead of saying export function, say goodbye, we could go down and we could say right here, for example, export default, say goodbye. Now we're going to save that one. And now we can, instead of importing like that, we can say import, say goodbye. And as you can see now, the syntax is slightly different. Instead of using those brackets right here, we're just going to say that we are going to import say goodbye from helper.js without the brackets. And now we can still call it the same way. We can refresh our code and we will get the exact same result. The reason is that now this here is a default export. The reason we do not need brackets here is because we cannot have many default exports right here. So this is not valid. If this would be another function, this would not work. You can only have one single default export for every single file, but you can have as many normal exports per file. So by using this syntax, you can essentially import as many functions as you want. If you do this syntax, you can just import one main function from every single file that you have exported as a default, essentially. So to sum up, if you want to use import and export, you have to declare it as a module. In a lot of frameworks, JavaScript files will by default under the hood be handled as a module. So if you can use import and export over there, this just means that the framework does the work for you of declaring this as a module. So if you ever work with a framework, which you potentially will, this is important to remember. Once it is declared as a module, you can use export to export function. You can use export default to export something as a default. And you can use import to import something. By using brackets, you are importing normal exports. By using import without brackets, you are importing a default export. What is JavaScript? JavaScript is a programming language that runs directly in the browser. It allows websites to be dynamic and interactive. It works hand in hand with HTML for structure and CSS for design. But what can JavaScript actually do? It can react to user actions like clicks, typing, or scrolling. It can change content and styles dynamically, validate forms, show pop-ups, or even load new data, all without reloading the page. JavaScript is the most widely used language for web development, and every modern browser supports it. Frameworks like React, Vue, and Angular are all built on top of it, and with Node.js, you can even use it on the backend. So in short, JavaScript is what brings your website to life. To understand how JavaScript works on the web, we first need to understand the DOM. When you write HTML code, it looks something like this. But JavaScript doesn't understand HTML directly. It's like HTML speaks German, while JavaScript only speaks English. So how can JavaScript interact with HTML code? The answer is the DOM. You can imagine the DOM as a tree structure that represents the entire HTML document and allows JavaScript to access, add, or manipulate elements. In reality, the DOM is represented as a JavaScript object model provided by the browser. That object contains other objects, each representing another layer of the HTML document. For example, if you want to display a div inside your HTML file, JavaScript can add it directly to the DOM. Every time you change something in the DOM, the browser re-renders that part of the page. So the DOM is what will be displayed inside of the browser. So to sum up, the DOM acts as a bridge between your JavaScript code and your HTML structure, making your website truly interactive. To get started, let's create a basic index.html file and a basic template by using the exclamation mark. Now let's also create a script.js file, and let's link the script.js file inside of our HTML file in the head. We can link our script file by using script:module. Now we need to define the source, which is script.js, and we need to set the def attribute because we're defining this inside of the head. And if we define the script tag inside of the head, we need to use defer, which tells the parser that this file right here should be parsed after the entire HTML and CSS code has been parsed. So this one should be parsed last. So how can we get a specific HTML element inside of JavaScript? First of all, let's create a div, for example, and we have a little bit of text in there. So how can we get a reference to this div container inside of JavaScript so we can later on, for example, change the content? In order to do so, we first of all can create a variable. This variable will store the reference to our div container in this case. And we can use any name we want to use. We could say div, for example. We could also say that or npc. And in our case, let's just use npc. So you see that actually anything works. We can now say that we want to get a reference to our document dot get element by tag name. And this one is going to be the right method for our purpose because we want to use the tag name to get a reference to this div right here. So we're going to use opening and closing brackets. And now we need to define the tag name. So what is the tag name of this div? The tag name is div. So we are going to say div right here. And now we can console.log npc right here, which is the variable name that we've defined for the reference to our tag name. We're going to go to our browser. You can see this is the text. And right here we have an HTML collection that holds this div right here that has a lot of data that we don't really need right now. And if I'm going to add another div inside of our index.html, or 2 more divs, you will see that we're going to get a bigger HTML collection. So now we have 3 divs instead of this collection. So the HTML tag name is an option, but as you can imagine, it's really hard to get a specific element right here. What if I wanted to get the second element, for example? And in order to do that, we can also use an ID, for example. So let's say we have a little bit of text right here, and now we have an ID, for example, that could be my minus text. Now we can also use this unique ID to fetch this paragraph by saying, for example, const text is going to be equal to document, and now we can use get element by ID, and right in those brackets we need to define, in quotation marks again, the name of the ID that we've used for our paragraph right here. In our case it's my minus text, so we're going to save that one. Now let's console.log our text, and you will see that this one works as well. So now we have a reference to our text, as you can see. There also exists the option to get a reference by class name. So now let's say this here is going to have a class of my minus second minus text. Let's copy that one. And now let's say const second text is going to be equal to document dot get element by class name, as you can see. And now we're just going to define, instead of quotation marks again, the class name. So my second text, for example. Let's save that one. Let's console.log our second text, and we are going to see in the console we have this HTML collection again for our second text. So if we are using a class name, you already saw this one was a collection, so I can also add a lot of paragraphs right here, and our collection will just get bigger and bigger. So by using a class name, we can obviously get a lot of references because a class is not unique, whereas an ID is unique. So if you use an ID, you only get a single element. If you use a class, you can get a lot of elements. And now you can access the individual elements, for example, by using bracket notation and 0, for example, or the index of the element. So this works exactly as you would work with arrays, essentially. And now, as you can see, we are getting my second text right here. So the first one of those elements that has the class my minus second minus text. Now let me delete all of this, and let me show you that you can also use the query selector to achieve the same result by saying, for example, const text is going to be equal to document.querySelector. And as you can see, we have 2 methods for the query selector. We have query selector and query selector all. So if you only want to get one single element, so the first element that is found within the document that fulfills the requirements, then you're going to use query selector like so. Otherwise, you're going to use query selector all. And I'll show you the difference. If you're going to use query selector, you can access an ID, you can access a class, you can access a tag, and so on. If you want to access an ID, you're going to say hashtag. So we can, for example, say hashtag my minus text. So my minus text. And now let's console.log our text right here. And as you can see, we're getting this text right here in the console. Now we could also say we want to get dot my minus second minus text. So now we're getting a class by using the dot operator. And as you can see, we're getting my minus second minus class, but only one element this time because we used query selector and we did not use query selector all. So let me show you. If we use query selector all, we're getting all of those classes as a node list. So now we could, for example, access an individual text by using the index, for example, like so. So this one here should be the second item that has the index of 1. Now we can also use a tag, for example. So we can just say, let's get a p tag, for example. And again, we're getting this result. And now let me show you that this also outputs a lot of p tags. So I'm going to remove that one. And as you can see, we're again getting a node list. And we can also use query selector, which will only give us the first paragraph. So by using the query selector, you can get a class, an ID, or a tag name, doesn't really matter. If you use the get element by tag name, you can only define a tag name. If you're going to use get element by ID, you have to define an ID. And if you use get element by class name, then you have to define a class to get the element. So all of those methods work. There's not really one method that is the best one. It's in the end more about preference. So how can we change the input of a certain element? Let's, for example, imagine we have this paragraph right here. And this paragraph, for example, has the ID of text. So now we want to have some text input inside of this paragraph. In order to do so, we first need to get this paragraph. We can, for example, create a reference to our paragraph by saying const text is equal to document get element by ID. The ID name is text, so we need to define that one here. And now there are 2 methods to to define text inside of this text element or inside of this paragraph to be precise. We can, for example, say text dot text content is going to be equal to this is the best course, for example. Now we're going to save that one. And as you can see, now we have this text content in here. So this text inside of this paragraph. The other method would be dot inner HTML. And as you can see, we get the same result. And if I'm going to change that text right here by adding at DSDSA or whatever, we're also getting this effect. So you can see this works as well. So what is the difference between text content and inner HTML? If we're going to use inner HTML, we could also use italic, for example, or other HTML tags right here, and they will be interpreted. So I'm going to show you by using italic right here. And as you can see, now this text right here is italic. So this HTML text will be interpreted. If we're going to use text content though, I'll show you the difference. And as you can see, now we get this I tag right here. So this I tag will not be executed as HTML code. And what is the difference? Text content is a little bit safer and it prevents cross-site scripting, whereas inner HTML obviously allows you to write HTML code inside of your text. But usually I definitely recommend you to use text content. As I already said, this is a lot safer. How can you get and set HTML attributes in JavaScript? Let's imagine we're going to have this link right here, and this one should redirect the user to Google, for example. So let's get the Google link right here, and let's copy and paste that one in here. So this anchor tag should redirect the user to Google. And as you can see, if we're going to click on this link, we're getting redirected to Google. So is there a way to get this attribute, for example? Let's give this element an ID of maybe Google. And now let's get a reference to that element instead of JavaScript by using const. And let's say this here's the link, for example. Now we're going to use document, get element by ID, and we're going to get our Google ID. And now let's, for example, just console.log link.get attribute. And we have to define the name of the attribute. In our case, the attribute name is href. So we want to get the href attribute of our link, which is this anchor link right here. Let's execute that one. And as you can see, we are getting the attribute right here inside of the console. Is there also a way to set a new attribute? And obviously there is. So you can also say link.set attribute. What kind of attribute do we want to set? Maybe in this case, we want to set the target attribute of our link. So this is the name of the attribute. And right next to the name, we also need to set the value for the attribute. And for our target, we could, for example, say that we want to use underline blank to open the page in a new tab. So we're going to save that one. Now we added for the link, the attribute target is equal to underline blank. So this is equal to doing target being equal to underline blank. So this is the exact same. Now we'll save that one. We are going to click this link, and as you can see, this link opens in a new tab. So we successfully added this attribute. So use the variable name that is a reference to your element, followed by get attribute to get an attribute, or followed by set attribute to set an attribute. Let me show you how you can use JavaScript to dynamically create HTML elements. Imagine we wanted to create an HTML element inside of this body right here. So we can go inside of JavaScript and we can say that we want to create a div. So let's say const div is equal to document.create element. So you use document.create element to create a new element. Now inside of the brackets, you need to define the tag name. What kind of element do we want to create? Let's say we want to create a div, for example. Now our div would essentially look like this, but it doesn't really have a place and it doesn't really have content yet. So we need to add content first. So let's add some content by saying div.text content is going to be equal to I am a div. We're going to save that one. So now we have this div, and this div also has text content, but this div will not be rendered yet on the HTML page because we're not telling it where it should be rendered. So we can, for example, get a reference to our body inside of our script file. So let's say const body is going to be equal to document get element by tag name, for example. And now let's just get the body. So now we have a reference to this body. And now we want to add our div element that we've created right here to this body element. So to this body. So we're essentially saying add this div to this body. And we can do so by saying body.append like so. And now we want to append an element. What kind of element do we want to append? We want to append our div element. So let's save that one. As you can see, we are not seeing anything because we need to say we want to get the first element from our body element, because we said get elements by tag name. We get multiple elements. So this is an array and we need to get the first element right here. And as you can see, now we're getting this div. So to sum up, we are first of all getting the body. This here is going to be an array. We are going to access the first element inside of the array because there only exists a single body. Then we're going to use .append to append an element. We created this div right here, and then we append this div to our body element. And I can also show you in the console what is going on right here. If we go to elements, you can see we have this body right here. We selected this body using JavaScript, and then we said that we want to add this div right here to this body. So we want to append this div to this body, and that is what's going on right here. Now there's also the option to remove an element. So let's, for example, use set timeout. And let's say after a certain amount of time, so let's say, for example, after 5 seconds, we want to use body of 0.remove. We want to remove an element. What kind of element do we want to remove? We want to remove this div right here. So we're going to specify this div right here as well. We're going to reload the page. As you can see, 1, 2, 3, 4, and 5. And now, as you can see, it is gone. So how can we use JavaScript to define styles for HTML elements? Let's imagine we are having this div right here. And let's say this div has an ID of container, for example. Now we want to get this container instead of JavaScript by saying const container is equal to document.get element by ID. And this one has the ID of container. So we're getting the element that has the ID of container. Now we want to style this container by using JavaScript. So we can say container. Now we can use .style, for example. And by using .style, we are saying we want to define or we want to have access to a CSS property. And right here, we have access to a lot of properties. So we can use bottom, for example. We can use left. We can also use background, for example. And in our case, let's say we want to use background. So let's say background is going to be equal to yellow, for example. Let's save that one. And as you can see, we're not seeing anything. And the reason for this is that we need a width and a height to set a background. So we can also say container.style.width is going to be equal to 100 pixels, and container.style.height is going to be equal to 100 pixels. Let's save that one. And as you can see, we're getting this yellow square right here. So usually you can just use the reference variable followed by a .style to access a CSS property, followed by the name of the CSS property, and then you can just use normal CSS code inside of those quotation marks to define a property. Now you can also use JavaScript to add a CSS class or remove a CSS class from an element. So let's, for example, say we create a style.css file, and we're also going to link the style.css file inside of our HTML code, like so. So now all of this code is valid. And now let's, for example, create a class of blue, for example. So .blue. Now we're going to say that class has a width of 200 pixels, a height of 200 pixels, and a background of blue, for example. So now let's create another div right below. And let's say that div has the ID of blue minus container. Now we can grab this blue container right here instead of our script tag by saying const blue container is equal to document get element by ID. We're going to grab the blue container. And now let's say we wanted to add the class name to this container right here. So we want to add the class blue to this container by using code. And we can do so by saying blue container dot class list dot add. And now we can add the class, for example, blue minus container. Or in our case, actually the class is just blue. So that was my bad. So we have to add the class blue. Now we are ending the statement by using a semicolon. And now we added the class blue to this element right here by using JavaScript. And as you can see, we have this blue container. We can also go ahead and remove this class by using blue container.classlist.remove instead of .add. And we can also define the class in here. And as you can see, now we have removed the class. And something that is important when you work with buttons later on is the toggle method. So you can also say blue container.classlist.toggle, and then you can define the class. And this essentially means if you have a class of blue, you're going to remove this class. But if you don't have a class of blue yet, then you're going to add the class. And this is important if you think about a button click, for example, and if the user clicks on a button and the class does not exist yet, you want to add the class. But if the class exists, you want to remove the class. Let me introduce you to events in JavaScript. And a lot of people think events are super complicated, but essentially they are really, really easy. What is an event? The easiest way to really show you is by just creating a button. And this button will, for example, have a text that is click me, for example. And now this button will also have an ID of btn, for example. So we'll really keep this one simple. So what would be an event in this case? An event is pretty much anything that is happening on a page. An event can be a click, for example. An event can be you scrolling. An event can you be typing in input. So an event is essentially just anything that you do on the page. So actually an event can be anything. And you can decide which kind of event you want to grab inside of JavaScript and what you want to do when this event occurs. So we could, for example, say, okay, we want to react to a button click. And if we want to do something, when a button click occurs, we have to add an event listener. So something listens to this event. Once this event happens, we are listening to the event and we can say, okay, now that this event occurred, we want to do something. In order to listen to an event, to a button event, for example, we first need to get a reference to the button. So we say const btn is equal to document get element by ID. We want to get our button. So now that we have a reference to this button right here, we need to add an event listener to this button because we want to say listen to all of the events that happen or to a specific event that happens for this button. So we can say button.add event listener. Now you have to use opening and closing brackets. This is a method. Instead of this method, you first have to define the type of event that you want to listen to. And there exist a lot of predefined types of events and you just have to remember them essentially. But I'm also going to be honest, the most important event that you'll always use is going to be the click event. So we'll define the event by using opening and closing brackets. And here you can see a lot of events, but you won't really need any of those ones besides a few. So the click event, as I said, is really important. So we can define that we want to listen to a click event for this button, for example. So once the user clicks on this button, we want to do something. What do we want to do? That is the second argument. So this here's the listener. Once the user clicks on a button, we want to execute this callback function right here. And for example, we can just say we want to console.log clicked, for example. And obviously this logic right here can be a lot more complex, but let's just keep it simple to really understand what is going on. And as you can see, if we're going into the console right now, we can say click me. And as you can see, this one has been clicked right now. Also, something that's really important, you're also getting an event object every time you're adding an event listener. So you can get this one, but we don't really need it in this case, so I didn't specify it right here. But I just want to make sure that you know that this is possible. And we can also just say that we want to log this event right here once we click on this button. So we can, for example, now click on a button. And as you can see, we're getting this pointer event right here. But in our case, it does not make sense. But for the next thing that we want to do, it might make sense. So maybe we also want to track the user input in an input field. So we are going to say we want to create an input field of type text. This one has an ID, for example, of username. So let's pretend this here is the username. Now we're going to get a reference by saying const username is going to be equal to document.get element by ID of username. So now we have a reference to our username. And now we want to add an event listener to this username input field. And we want to see what kind of input the user types in there. Or we want to track that. So we say username.add event listener. In this scenario, we maybe want to listen to the input event because the user types in some input. And right here, we can actually say that we want to get the event or the event object, but I'm going to say this one here is E. And this is also a convention, so a lot of people say that this here is just E. And now we can also just say, let's add console.log, and let's just add our E, so our event. Now let's type some stuff in here, and as you can see, we're getting this input event. So now we have a lot of stuff in here. And something that you'll use very often is this target property right here. So e.target, for example. And as you can see, you have really a lot of properties in here. But one of the properties that is really important in there is the value property. But let me first of all show you e.target. So we'll access, instead of this object, the target property. And this target object has the value property. So now let's save that one. And now let me type something in. And as you can see, we're getting the value as an output in the console. Let me show you one more event that might be kind of important. So let's, for example, say we create a form of type post. And inside of this form, we are going to have a submit button. So button:submit. And usually when you press a button, so let's just say submit. And usually when you press a button, you will have a reload of the page. So take a look at the top right here. If I'm going to submit right here, you can see we're getting a reload and the page isn't working. So maybe this is something that you don't want to have. because this here is the default behavior of HTML elements. So we are going to grab this form by saying this one has an ID of form, for example. So let's keep it simple. And we're going to say const form is going to be equal to document get element by ID of form. Now we are getting our form. We are going to add an event listener by saying form.add event listener. What kind of event do we want to listen to? We want to listen to a submit event because right here the user is submitting data. So we are going to say submit is the event that we're looking for. We are again going to get our event object right here. And now if you want to prevent the default behavior of reloading, for example, you can use e.preventDefault, which is a method, and we'll end that statement by using a semicolon. So now let me show you, once I press the submit button, nothing is happening. So now we could also say right here, console.log, we clicked, and we're going to go in here. And as you can see, we clicked will appear in the console, but we will prevent the default behavior of reloading the page once we submit, essentially. And that is something that is pretty useful, especially if you want to define all of your logic yourself instead of JavaScript, for example. So now we could also say that we want to create an alert, for example, that says, hey, yo, or wayo, doesn't really matter. Now we're going to click, and as you can see, we're getting this alert that has the message wayo, for example. So those are the most important events. I actually never really used a lot more myself. So I think if you know them, you're really good to go. But just keep in mind that there exist a lot more events, and maybe in the future you might need some, and then you can always go and take a look at the documentation. Let's understand setTimeout and setInterval. And those functions are actually super easy. Let's start by using setTimeout like so. And by using setTimeout, you're executing the method and it accepts a callback function. Inside of those brackets, you can define what you want to do when calling this method. So in our case, let's use a callback function right here. And right after the callback function, you can use a comma separated by a value right here. And this value defines in milliseconds how much time it will take to execute the method body inside of here. By saying 1000 right here, we say wait for 1000 milliseconds, so for 1 second, and after that second, execute the code that you have inside of this body right here. So we can, for example, just say console.log 1 second pass, for example. Let's save that code and let's execute that code by using run code. And as you can see, we're waiting and 1 second passed. Let me show you that this in fact works. I'm going to say this here executes after 2 seconds, and right here I'll say 2 seconds passed, and I'm also going to use 5 seconds so that we really see what is going on right here. So I'm going to execute the code once again, and as you can see, 1 second passed, 2 seconds passed, and 5 seconds passed. So setTimeout is pretty simple. You just define what you want to do after a specific time right here, and after a comma, you define a time in milliseconds that you have to wait until you execute the code inside of the body. SetInterval is pretty similar. The only difference is that you define an interval and you keep doing whatever you have in your method body forever. So let me show you. We're going to setInterval. Again, we take a callback function right here. We can, for example, say console.log getting called every single second. So this line gets called every single second. And right now we also have to define a time, which can be 1 second, for example, in our case, because we want to call this function every single second. But obviously it's up to you what kind of time you're going to define right here. So now let's execute this code. And as you can see, getting called every single second gets called every single second, whereas the setTimeout function only gets called 1 single time. In some cases, you might want to turn an object into a string. And a use case that you will often need is if you want to send data via the internet, or if you want to save data inside of the local storage of a user, for example. And the reason is, for example, if the user, for example, accesses your website like this, then you have the option to, for example, save something inside of the local storage of the user. And the local storage is essentially a storage that sits on the website of the user. So essentially you save the data in the browser of the user. And this can be especially useful if you think about a shopping cart, for example. So imagine we save the amount of items that the user has inside of the shopping cart. Then you maybe want to add the amount of items that the user has added to his cart, for example, to the local storage. So once the user quits the website and revisits the website, he still sees all of the items that he has inside of the cart, because it's obviously not the best user experience if the user quits your page, for example, and everything is gone. And in order to do so, we need to save something inside of the local storage, for example. But we can not save an object like this in the local storage. And in order to save this one, we need to create a string. And we can create this user string, for example, by saying that we want to use JSON.stringify like this. And then we pass our object inside of those brackets. We're going to save this. And now we are going to console.log our user string to really see what's going on here. And this here should be a string right now that we can send to the local storage, for example. Now let's imagine we want to have the original form again. Then we can say user original, for example, is equal to JSON.parse. And let's enter the user string, for example. And now let's also console.log right here our user original. And we will just run this code again. And as you can see, this here is the original one. So we've parsed it and turned it into an object again. And this here is the stringified version. If you want to save the data to the local storage, for example, or send them by the internet, you can first use JSON.stringify. But if you know that you're going to receive one of those strings, you can use JSON.parse to turn them into the original form again. So if you say you want to receive this data and work with this data, then you turn this one into the original form again and can work with it. So you have the original object. And if you want to turn it or send it to the local storage, you can use JSON.stringify to stringify the object, for example. So let's say we saved the card of the user, for example. And inside of this card is essentially an object. We have an amount of items. So let's say he has bought 2 items or has added 2 items to his shopping cart at this point. And let's say this here is the amount. And then let's say the items, for example, are an array. And we have some sneakers in there, for example, and some Jordans. So let's just say this represents a simple shopping cart of a user. And now we somehow want to make sure that once the user enters those items to the shopping cart, leaves the website and comes back to this website, the items are still in the shopping cart. Because it would be a probably pretty bad user experience if all of those items are gone. And we can do so by using the local storage. And let's take a look at the website. Once we inspect this website, we see that we can go to the application tab right here, and we can go to the local storage. And this here is the local storage, and we save key value pairs inside of the local storage. So this local storage is nothing that really has anything to do with a server, but rather is a storage on the PC inside of the browser of the user. So this local storage is not that big and it belongs to the browser of the user. So every time you want to save info like your shopping cart, for example, this is the way to do it. And especially if you think about a website where you, for example, don't need the user to be logged in and you don't want to query the database all of the time to get every single detail like the shopping cart, this would be the perfect opportunity to use the local storage. So let's say we want to save those items in local storage. And all I've done is essentially create this index.html and I've linked our index.js file to this index.html. So we are executing this JavaScript code that we are writing right here inside of the browser. So now let's say we're going to use the local storage, and there are 2 methods. The first one is set item and the second one is get item. And as the names imply, one is for setting the item in the local storage and the other one is for getting the item from the local storage. So you can set item. You first pass a key and you second pass a value. So this is the basic structure. So for our key, we could, for example, say, let's call this card items, for example. So I'm not going to name this one card because I want to show you that this is really, that you can really name this whatever you want. And then you have to pass in the value right here. So the value in our case is our card because we want to save our card to the local storage. So let's save this. Let's go inside of our browser. And as you can see now, we already have those card items inside of our saved to our local storage. But as you can see, the value is an object right now. And as I've mentioned in a previous episode, we cannot save an object to the local storage. And in order to save this card to the local storage, we have to turn it into a JSON string. So we are going to say JSON.stringify and we will pass this object to our JSON.stringify method. So now we're going to save this again. And as you can see, now we can read this value inside of our local storage. We have an amount of 2 and our items right here. Now let's also say we want to get those items from the local storage again and maybe console.log them. So let's now say local storage.get item. And once we want to get an item, we need to use the key. So we can say the key in our case is card minus items because that was the key that we've defined for our set items function. And now let's store those items. Let's say const card items is equal to local storage.get items. So now we can use those card items So now we want to log those items, let's say in a console, for example. So we can say console.log, and let's log our card items. Let's save this one. Let's go to our website and let's switch from our application tab to our console tab right here. And now as you can see, we get this item right here. But if we wanted to read those items inside of our console, we would actually need to use card items inside of a JSON.parse method. So we would have to enter them in here because first of all, we've created a string to save this inside of the local storage. But if we want to use this one as an object again inside of our JavaScript application, we have to parse this JSON string essentially. So let's console.log our card items and the parsed version. And as you can see, this here really looks like an object. The second one, the parsed version, whereas the first one looks like a JSON string. And is all you really need to know to understand the local storage in JavaScript. Let me show you the session storage. If you want to save an item to the session storage, you can use session storage.setItem. We can say that we want to set the username. As you can see, the username is going to be our key. This one is going to be a string. And now we can also say that we want to set a value right here. And let's say our username is Yapo, for example. So we are going to save this one. We can go to the application tab. Right here, you can see that we have the local storage, for example, but we also have the session storage right here. If you open the session storage, you can see that we have the username of Yapo. But nevertheless, what is the difference between the local storage and the session storage? The local storage will consist even if we refresh the page over a long time, while the session storage will get lost once we reload the page, for example, or switch to a different tab and so on. So the session storage is only available for one single session, and one single session goes up to the point where you leave the page or leave the tab. The local storage is usually available for a lot of sessions. So even if you go to a different page, for example, quit this page right here, open the page once again, and so on, you will still have the local storage, whereas the session storage is usually gone at this point. Let's understand cookies in JavaScript. Cookies are somewhat similar to sessions and the local storage, but they are also different, and understanding the difference is really important. So let's go to the application tab right here. And right here you can see we have, for example, the local storage, we have the session storage, and we also have the cookies right here. So we have the cookies for this URL, for example, as you can see. And now you can also clear the cookies. Now they're all gone. And as I've already mentioned, the local storage will be stored inside of the browser and will persist over many sessions. So even after reloading the session, the local storage will be there. The session, as the name implies, will persist over one single session. So every time you reload the page, for example, or go to a new tab, the session will be clear. Cookies, on the other hand, can also persist over many sessions, but the difference is that every time you send a request to your server, for example, and get a response, you also add this cookie to the request. So this is really good to authenticate the user, for example. So you can, for example, store a user ID inside of this cookie. You can send the request. If you want to get data, for example, the cookie will be automatically sent with this request. The server will see, okay, we have the user ID. So this is a valid user right now that is logged in, and I can reply with the data, for example. And it's also important to understand that usually if you want to save a user ID, for example, as a cookie, you don't do that via JavaScript because that is something that should be handled using PHP. But you can also set data using JavaScript inside of a cookie, and that should obviously be data that is not that important, not that relevant. So we can set a cookie by saying document.cookie. Now we can set this to a string, for example. Right here, we can, for example, say that a monkey is equal to ayo. Now we can use a semicolon. Right here we also need to set an expiration date. So we can say expires is equal to, and right here we need to have a pretty long timestamp. And I actually can't really remember the syntax, and I don't recommend you to do this. So you can actually just generate a new date. So you can say const date is equal to new date. So we're going to create a date object. Now we can say date dot set date. We're going to set a date. We're going to say date dot get date. We're going to get the date of our date object that consists the current date. And now we can say, for example, that we want to add 7 to that date. So by using the syntax, we're saying add 7 days to the current date. So this date will be 7 days in the future right now. And now we can insert our variable right here into the string by using this syntax, and we can say date.toUtc string, which will convert this string to the perfect format that we're going to need for this expires field right here. Now we also need to define a path, and that one can be equal to a slash, which means this cookie is valid for the entire website. Now let's save that one. We can go into the browser, we can refresh the page. Now as you can see, we have this cookie. It has a key or a name of monkey and a value of AO. If we want to get this cookie, we can for example say, let's console.log this cookie by saying document.cookie. So setting the cookie and getting the cookie has the exact same syntax right here. Let's go to our console. And as you can see, we're right here at the top getting monkey is equal to AO. If you wanted to delete the cookie, we could just go ahead, copy that line, for example, paste it in here. Now we can also update the date. So let's say we're going to use a different date. We're going to say date.setDate is date.getDate +7. Instead of +7, we are going to say -7, for example. This does not need to be -7, but it needs to be any point in the past. Because if a cookie expires in the past, it will be deleted. So we're going to do that one. We're going to set the cookie once again. And now let me console.log document.cookie right again. And this here should be the deleted cookie. So I'm going to add that one as well. We're going to console.log that. We're going to reload our page. And as you can see, we're only getting the line deleted cookie, but we're not getting any information right after because the cookie is now deleted. We can also take a look at this in the application tab. If we take a look at the cookies tab, we are not having any cookies anymore because the cookie is deleted. Let me introduce you to the window, document, navigator, and location object. In order to do so, I think it makes sense to console.log our window object. Now let's go into the browser, inspect, and in the console we can see that we're getting this window object right here, which includes a lot of stuff. It includes the history, it includes the document, it includes alert, and so on. So the window document is essentially what represents your window, and this window object includes everything. So we could, for example, say, let's get window.innerHeight. And by doing so, we will get the inner height, so the height of this window right here. And as you can see, the height right now is 910 pixels. We can also get the inner width, for example. So let's save that one. And as you can see, the width is 1331 pixels. If I'm going to make this one a little bit smaller by making the console bigger, and I'm going to reload, you can see now it only has a width of 1143 pixels. So this might be kind of useful from time to time. Now you also have the document object. As you can see, let's log that one. We have this document object right here, which you also use pretty often, if you remember, by saying document.getElementById. So you can use that one, for example, to get elements from the DOM by their ID, for example, by their class name, by their tag name, and so on. So this is pretty useful about the document. You can also say that you want to add an event listener, for example, to the document. Let's listen to click events. And we're going to console.log clicked once we clicked the document. So let's see what is the document. I'm going to click in here, and as you can see, pretty much everything is the document. So the document represents your HTML website. So the window includes everything. The document includes your HTML website. Now let's use the navigator. The navigator gives you a lot of information about connection, for example, about the device, and so on. In my opinion, it's not that important, but I want to show it to you very quick. So you can, for example, say navigator.online, and now we can just console.log that one. So you see what is going on right here. And as you can see, we're getting true inside of the console. What is navigator.online for? This one checks whether you have an internet connection right now. If you have an internet connection, this will return true. Otherwise, it will return false. And now let me also show you the location object. So first of all, let's console.log location, for example, .href, and let's go into the browser. And as you can see, we're getting this website right here. So we're getting the current URL. So location in general is an object that includes information about the current location, as you can see. And you can, for example, access the host name, the host, the path name, the port, and so on. But most of the time you want to use href because that is the complete path to your current page. So if you wanted to change the page, for example, you could say location.href is going to be equal, and now we can say slash, which means we're going to use the default host right here. And after the host, we want to say contact.html, for example. So once we get to the index.html page, we are loading this script.js file right here. Once we load the script.js file, we're saying, okay, now navigate the user to our /contact.html page. I'm going to reload the page. And once I go into the browser, you can see that we cannot get the contact.html file because we don't have that file now. But if you take a look at the URL, you see that this in fact did work because we now navigated to our contact.html URL. And if we would have a contact.html, like so, for example, and I would say wayo, for example, or whatever, you can see that this one works. Now, if I'm going to go to our index.html file, I get redirected to our contact.html immediately because we run the script file. Let me introduce you to alert, prompt, and confirm. Let's start by using confirm, for example. So I'm going to say confirm, are you above 18, for example. I'm going to save that one. Let's load our index.html file right here. As you can see, once we get to the index.html file, we are getting this notification that asks whether I'm above 18 or not. So let's press OK right here. And as you can see, the notification disappeared. But maybe we want to get that value. So we can, for example, say const age is equal to this confirm message. And now just console.log the age value to see how this one looks. So we're going to press OK. And as you can see, we're now getting true. So you could use this one, for example, to check whether the user is 18. If he isn't 18, you can deny access to the page. And if he is 18, you can grant access to the page. So this would be a possible scenario. Now, there also exists the prompt mechanism, like so. And now you can, for example, ask, what is your name? And in this case, username might be a more descriptive variable name. So let's do that. And as you can see, we get this input right here where we can enter a name, for example. So I can say I'm Peter, for example. I saved that one, and as you can see, nothing really happened. But let's console.log our username to see whether we really got this value right here. Username, like so. And let's say I'm an NPC, for example. And now, as you can see, we're getting this value right here. So can we use this value now? Obviously we can, but we could also use it with an alert, for example. So let's now test an alert and say, hello. And now we are going to add our username that we've just gotten by using this prompt right here. So we're getting this prompt. We can say I'm an NPC. I'm going to press OK. And now we're getting this alert right here, which says hello NPC. So the first one was a prompt and the second one was an alert. Let me introduce you to the history in JavaScript. Imagine we are having this HTML file and we have an H1 right here, for example, that says this is, or that just says home, for example. And now we also have two more pages, like a contact.html and an about.html. Let's create a basic template and let's say this one here is about and this one here is our contact, like so. And now let's also create a short navigation bar. So we have an anchor right here that redirects the user to our home or index.html file. This here is home. Let's duplicate that one. This here is going to be contact and this here is going to be about. Doesn't really matter too much though. So this is contact and this is about. And now let's just copy those anchor tags right here and paste them on our about page and on our index.html page. And as you can see, now we have this navigation. We have home, contact, and about. And about somehow does not seem to have the anchors for whatever. Okay, now it works. So now maybe we want to use JavaScript to navigate on our page. So we can, for example, say on our index.html file, let's create a button that has the ID button, for example. And that one says, click me. We're going to get this button inside of JavaScript by using const btn is equal to document get element by ID btn. And now we want to do something once the user clicks on this button. How can we do something? We are going to add an event listener. We are going to listen to the click event. Once the user clicks on the button, let's, for example, say we just want to log our history, because that is ultimately what we need to redirect the user on a button click. So let's first take a look at that. Let's go to our homepage. We have this button right here. And as you can see, now we're getting this history object right here. And you can see we have a lot of properties right here, like back, forward, go, push state, replace state, and so on. And the most important ones, in my opinion, are back, forward, and go. And as the names imply, back goes backward, forward goes forward, and go allows you to be more precise. For example, if we click this button, let's say we want to use history.back, so we're getting back to the previous page that we visited. So we're going to go to contact. From contact, let's go back to home. So now our previous page was contact. We're going to click this button. And as you can see, we are getting redirected to the contact page. Now let's use forward, for example. And forward is a little bit tricky. So let me show you. We're going to contact, home, click me, nothing happens. Why doesn't anything happen? Well, because this is our newest page, since we never went back. So we have to go back in order to be able to use this button right here to jump forward. So now let's test that. Let's go from our home page to our contact page. Now let's go backward. So now we went back to our home page, and the next page would again be our contact page because that was the page where we pressed back. So now let's click this button and we're getting redirected to the contact page. Also, if we would go to the home page, go to about, then we're going back. We're now again on the home page, but we press the back button on the about page. So that one would be the page if we go forward. So let's click that button, and as you can see, we're now on the about page. And now you can also use go, for example. And go is pretty simple. You just enter a value, so a number. Do you want to go forward? Maybe you want to go one page forward, then we use 1. Maybe you want to go one page backward, then we use -1. Maybe you want to go 2 pages backwards, then we use -2, for example. So this is really simple. Now let's test that one. Let's click on contact, let's click on about, and let's go to home, click me, and as you can see, we're landing on the contact page. Why the contact page? Because that was the page where we have been 2 clicks ago. So let me show you. We're starting at the home page. First click, contact page. Second click, about us page. Third click, home page. So if I'm going to click right here now, we're going to go 1 level back, about, 2 levels back, contact. So we should land on a contact page. And as you can see, we land on a contact page.